Welcome everyone to another episode of our Live Days. My name is Benedict, I'm Community Manager here at WeAreDevelopers, and I'm glad that you all joined us today. Before we start with the first speaker of today, I got some information to share with you. First, we have a giveaway. Together with our partner Deloitte, we want to offer you a MetaQuest 2 VR gaming headset. All you have to do for it is scroll down on the live page and sign up, and you're good to go. Second, if you know us from an in-person event or live days, maybe you already know that we have a soft spot in our heart for our beloved rubber ducks. And some time ago, this happened.
Would need to say makes the web better place still for at least the next 500 years.
Probably you've already recognized him. Yes, it's Håkon William Lee, the inventor of CSS, signing one of our rubber ducks. But the best part is you can win one of them. All you have to do for it is to sign up for our Dev Digest newsletter. You find the link in the comments. And last but not least, I'm very happy that I can tell you that we will announce the date of our upcoming WeAreDevelopers World Congress 2023 episode very soon. To stay tuned for it and to claim your benefit from a discount code, just pre-register at worldcongress.dev. You'll find the link also in the comments. And now, before we start with the first speaker of today, remember, feel free to interact with the chat to your right, submit your questions in the Q&A section, but as always, be nice to each other, respect each other. We have a code of conduct. Here's a short video about it. And now for the first speaker of the day. He's solutions engineer in the DevOps team of Deloitte. And with his master's degree in computer engineering, he certainly knows what he's talking about. Welcome, Thomas.
Hi, Benedict. Nice to be here.
Hi, Thomas. Thanks for joining. How are you doing today?
I'm fine. You too?
I'm fine too. Thank you so much. So, Thomas, maybe you want to tell the audience and me a little bit about what we are going to learn from you today.
Today, I will talk about feature environments. So to explain that, let's imagine you're working with a cloud provider like AWS, and which provides the infrastructure for you. And you want to change this infrastructure. And it would be really great to create a copy of this infrastructure, change something there on this feature environment, and then merge it back to your real infrastructure. And yes.
Okay, sounds interesting, Thomas.
Yes.
I'm looking for your talk. I bet the audience is too. So I would say stage is all yours.
All right, then I will share my screen. Wait a second. Okay. I hope you can see my presentation. Yes. So, all right. That's a slide for me.
Thomas, we can't see it right now. Have you shared your screen already?
Okay. Wait a second. One moment.
Computer says no.
Computer says no. Now?
Yes. Now we're good to go.
Nice. Okay, I will start the presentation. So the first slide is about myself. Yes, as Benedict already mentioned, I'm a solution engineer at Deloitte. There I work in a talent group, which is like a department of Deloitte, which with the name Cloud Transformation and Systems Engineering, the abbreviation is CTSE. I'm from Berlin. I also studied there in Berlin at the TU Berlin. I studied in my bachelor as well as in my master's computer engineering. And I'm AWS and also Terraform certified. Okay, this is my agenda of my presentation today. First, I will talk about what are feature environments to get an idea about that. Then I will talk about the advantages of them and disadvantages. And then I will show you how we can implement this feature environments using Terraform. And then I also show you how we can implement this using a CI/CD pipeline. Okay, let's go to the first slide here, and I will pick the laser pointer functionality. Okay, and we will stay for a while on this slide to explain what feature environments are. And when you have feature environments, you maybe think of feature branches, and this is already good. So let's assume that you're using a cloud provider like AWS where you get your infrastructure from, and you're describing this infrastructure as a code. And what you can see here is the Git repository of your infrastructure. And this is the main branch of your infrastructure. And here you can see the different resources you have for your application. Let's assume that you have an S3 bucket there, or AWS Lambda. It's serverless functions for AWS. Amazon ECS, it's an elastic container service to manage your containers, API gateway, and different services. Yes, and now assume this is the only infrastructure you have to develop your infrastructure, and now you want to change something on this infrastructure. For example, you want to migrate from ECS, this container service from Amazon, to EKS. It's the elastic Kubernetes service. It's a managed Kubernetes service of AWS. And yes, and you have only this specific infrastructure on the main branch, then, and you are changing this, then you're maybe blocking the development of other feature environments, of other features. Or you want to, for example, replace, you are currently using an API key for your to secure your API, and you want to use Cognito. It's a user pool management of AWS, and yes, you want to do this, but you don't want to block the development of other features. And to do this, you can't do anything regarding this topic locally on your local machine. So it's very beneficial to, yes, simply create a feature branch now from this main branch, and then automatically via CI/CD pipeline create an exact copy of your current infrastructure, a short-lived copy. So you only do your changes on this short-lived copy of your infrastructure there, and then merge it back and destroy your current the infrastructure of this feature branch. And you can, yes, and in this way you can work on different branches. So this is feature branch 1 and feature branch 2, and you have all the copied infrastructure from this, and you can work on this infrastructure, make your changes there, test everything if it's working with the current infrastructure, and do not affect your real infrastructure. That's very beneficial. And yes, so now we will jump to the slide of advantages of this and disadvantages. So the most important thing is that you avoid the blocking of the feature development, because you can work on this dedicated feature environment, and another developer can work on another feature environment without blocking each other. Then there's another point is that you can also test those new features in this isolated environment with a copy of your real infrastructure, so you are not restricted by anything in this matter. Another point is that you can create everything automatically via CI/CD pipeline, so you don't have to you do not have to create the whole infrastructure in a manual way. And if you, yes, when you created this feature environment, and anything is broken, oh no, yes, you messed something up, you can simply destroy your whole infrastructure and recreate this, and without impacting other developers or the development of other features. Here are some disadvantages. There are some additional costs for the additional infrastructure, but on the other hand, you save money because developers are not blocked. Then another point is that the development of those feature environments comes with an additional effort. And also the team needs a bit of practice to use these feature environments. For example, they have to choose when you have different databases and you have a database for each branch, the developer must know which database they have to choose. And also the creation of these feature environments takes some time to create and spin everything up after you have created a feature branch. Okay, here I've added a slide because we are using Terraform for that. I've added a slide how Terraform actually works, if you are not aware of that. So on this slide, it's the infrastructure as a code tool. And in this slide, you see here different cloud providers like AWS, GCP from Google, Azure from Microsoft, Kubernetes, Alibaba Cloud, different cloud providers where you can get the infrastructure from. That's here, the infrastructure. And with Terraform, and you can access the resource, the infrastructure from those cloud providers using, for example, their web console, but they are also offering, for example, an CLI to create the resources for you. And there are also different ways. They also offer an API to create those infrastructure resources. And Terraform is now using this API of those cloud providers, and you simply can describe your infrastructure there as a code with Terraform. So let's say I want to have a database with this and this arguments, and you can do this as a practitioner, and then Terraform will translate this code into API calls for these cloud providers, and then this infrastructure is generated. And those are 2 comments from Terraform. Okay. This is the next question. How we are now implementing feature environments with Terraform, because yes, our main goal is to create a new branch and then spin up an exact copy of our current infrastructure. And how do we do this with Terraform? And for that, I've created an hands-on example because we have to understand the concept of Terraform workspaces. For that, we are using Terraform workspaces. And now I will go to my console. I hope you can see that. Yes. Here I'm using PyCharm. Okay. Yes. First of all, here I have an empty directory. So it's a very simple example where we can do everything by from scratch. Here, the first thing I will do is now I will create some resources. So I will, to explain Terraform workspaces, first I will create 2 files, main TF and backend TF. Now we can see those files occur here. We have to modify this backend TF file. It's a small change to specify where our state files get stored and locally. That's all for this. And here we now wanna create a resource with Terraform, and the resource we wanna create, it's not a database or a serverless function or I don't know, some other resources. The resource we wanna now create is a random string with Terraform. Let's name it our nice random string. Here you can specify the length of this random string. And now we have to perform a Terraform init to initialize everything and perform a Terraform plan to see what Terraform will create for us. And Terraform say to us, hey, Terraform will create a random string for us. And those are specific arguments for that. For example, the length of this random string is 10, and we are using special characters, we are using numeric values, and so on. But we can also change this. So we can, for example, take this numeric and set this to false. Then our random string will not contain a numeric value. And when we perform now a Terraform plan again, we can see this one is set to false. we have also this nice comment here, Terraform format. Then it's format the code. It's nice. Okay. All right. And when we now do a Terraform apply, we can see that Terraform will create this resource for us. And when you have a look, before we are doing that, when we have a look at this corner here, we are seeing those 4 files. Okay, yes. And when we now create this with Terraform apply, we can see this random string, this resource which was created in the Terraform state. Wait, I will put the Terraform state file here. Right. So we have on the left side, we have now our main TF file, so the Terraform configuration file of our resource. And on the right side, we have the state file of the resource we have created. And here we can see our resource, random string, our nice random string, and we can also see how the string looks like we have created result. Okay, so now we can come to Terraform workspaces. Let's jump back to the CLI for that. Terraform workspace. Let's first have a look at the help of this Terraform workspace. You can see it, we can delete workspace, we can list a workspace, create a new one, select a workspace, and we can also show the name of the current workspace. Let's do that. Terraform workspace show. And we can see, hey, we are using the default workspace. So we have, as we saw, we had an empty directory, created a new project here, and Terraform will start with the default workspace. And when we list our current workspaces, yes, it's a default one. So, but okay, how do we now use this workspace functionality to create a feature environment when we create a new feature branch? So we can now, with Terraform workspace new, we can create a new workspace. And how should the workspace name looks like? In the end, what we planning to do is that we are now using the exact name of our feature branch. So the workspace name relates to our feature branch. Let's say in GitHub, GitLab, Azure DevOps, we are creating a branch, and then we perform this comment here, but this comment is then at a later point automated via CI/CD pipeline. So we will create a new workspace with the name of our feature branch. Let's say feature/feature1, or we can also delete this prefix here and just name it feature1. And now Terraform will create a new workspace for us, and it switched already to that. It's feature1. When we now do a Terraform workspace list, we see, hey, we are on this other workspace. Let's now perform a Terraform apply to again create the resource, in this case this random string. Okay, one to add, it's nice. And what we can now see here in the files, Terraform created a folder here named terraform.tfstate.d. That's the folder name. And another folder, feature1. That's exactly the same name of our workspace. And inside this folder is now a second Terraform state. I will put it here. Exactly. Now we have two Terraform state files. Terraform TF state here for our feature environment, and this TF state is from our default workspace. And that's already a nice way how Terraform handled that, because you can see on the left side we have only one configuration file of our infrastructure, which is now only a random string, here. But we can have different Terraform state files, and that's really a nice way. So, and here we have this random string, and here we have another one, this one. Nice. The next thing we want to do is to create a file, local file, my nice local file as a name, and let's call it local file text. And the content of this file we want to create, Terraform will create for us, is our random string, our nice random string, the result of this. Okay, we have stored here. We can see it in the state file. Let's do apply again. Because we are now using a new resource, a new provider, in Terraform, we have to initialize it again. So perform a Terraform init, and now we can do a Terraform apply. Nice. So Terraform creates now this new local file for us, and we can see it somewhere here. There's it. And the content of this local file is, there's the result of the random string. That's nice. And we are currently, when we look at our workspace list, look at our workspace, we are currently on feature 1 workspace. When we now go back to the other one, we are switched to workspace default and would now create also this file there. What would happen? What would happen to this local file? It would be overwritten to yes, the state file of the default one. We have 2 different random strings, this one of this and this one of that one. That would be bad. Let's do this. Yes, so we have to change the name of our local file. And there's this nice keyword in Terraform. And the name of this keyword is Terraform workspace. So in this way, Terraform workspace, we can add the name of our current workspace to the name of the local file which gets created. Let's do that with another apply command. And you can see what Terraform will do for us. It will replace this local file. It will replace the local file with local file underscore default, because we are currently on the default workspace, and it will replace this. Nice. Let's do this. And let's update this. Now we have here this file, and let's go back, go to the other workspace, select feature 1, and I will also perform here an apply command and create a resource. The resource will be created, and we can also see here now the other local file. And in the end, we do not have files here. It's just an example, just text files. In the end, we have our different databases, and they, as the file, they also need to have another name. They can't have the same name. So the way how we deal with this is to use a suffix and put the name of the workspace, which relates to to our feature branch name, at the end of the related infrastructure. Let's create a new workspace now. Workspace new feature 2. Let's call it feature 2. And perform here another apply. Now 2 resources will be created. Oh. Wait a moment. Yes. All right. Apply complete. What we can see now is that we have 3 text files, which contains our different random strings and our different state files. We have now the default one, the default state file here. We have now those 2 folders inside this Terraform tfstate folder, which relates to our 2 workspaces. And I will mark them. We have now those three state files. And that's really nice. You know, we have only one configuration, but different state files. And in this way, let's do a Terraform workspace list again. Yes, we can have this different different workspaces and have a different state for that and create multiple times our resources, which we can see here. But in the end, yes, as I said, it's not text files. It can be an S3 bucket, it can be a database, it can be a serverless Lambda function. And yes, that's the way how Terraform handles this. Okay, let's jump back to, that's what I want to show you. Let's jump back to the presentation. And here I have 2 slides for that, which I showed you. On the left side here, you can see the Terraform configuration. We saw it, main.tf, the file, and which we can see on this slide is another resource. It's in this now it's not a random string. It's an AWS S3 bucket, my new S3 bucket, and it's the name of the bucket. And S3 bucket stands for Simple Storage Service. It's the object storage service of AWS, where you can put files and store files there. And we also saw this configuration file is now related to a Terraform workspace, the default one we saw, or in this case, I called it main in the slide. And we have also a main state file for that. And when we create this resource, we can, in AWS, we can create out of this infrastructure as a code lines, we can create this S3 bucket in AWS. And when we are now using multiple workspaces, we also saw it before. Here we have again the configuration file, and here we can see also the adjustment. Here I've added this keyword terraform.workspace. I will jump back here. I don't have this suffix. Here I have it, and you can also add this as a tag, Terraform workspace. And because the name of the S3 bucket needs to be unique, and it cannot have the same name. Yes, and in this way, because we have only used this using this variable here in the configuration file, we can have different states, different with Terraform workspace. So here we can have the main workspace with the main state file, and we can also have a feature branch with the feature one name and can have a state file there. And then in this way, we can create with one configuration file different S3 buckets for the main environment and also for the feature environment, feature one environment. On this slide, you can see how it's, here you can see the AWS console, web console of the Amazon S3 service. Here I want to show you how, yes, I've redacted some parts of the slide, but here you can show how it's implemented, and here you can see how the resources were created in AWS. So here you can see 3 buckets. You have a bucket name, bucket, and then you have a hyphen, and then it comes, we saw it before, the name of the Terraform workspace, which relates to your feature branch, which is in this case master. And another person has created, another developer created the feature branch user management something, and then this developer can work on this S3 bucket and maybe can change the permissions or something like this and see if it's working or not. And then when he's working this bucket, he do not disturb other developers. For example, this developer who's working on this on another feature on this S3 bucket. And when the developer is done with that and test everything, then he can merge it back to the master branch, and then also the master infrastructure gets updated. Okay, but yes, now it comes to a downside. There are AWS naming restrictions, and there are a lot of them. This is just as an example. And there are a lot of services from AWS, and this is only one service. So the S3 service, only one service, and you have naming restrictions there. And here I cut it here, This S3 bucket we saw here before must apply the following rules. This bucket name must, for example, be between 3 and 63 characters long. And the bucket name can only consist of lowercase letters, numbers, dots, and so on. So not uppercase letters. And the bucket name must begin and end with a letter or number, and so on. And that's not the whole list, and just for one resource. So this is related to exactly this name, but we know this suffix here relates to the feature branch name. So what if the developer creates a feature branch which is 100 characters long in GitHub or GitLab or something like this, and then he wanna add the suffix to an S3 bucket, you know, that you can know to which feature environment this relates. And for this, you have multiple solutions to deal with this problem. You can, for example, but that's not a nice one, you can go to the developer and say, hey, please, when you create a feature branch, then please do not use uppercase letters or something like this, or not using numbers, but that's not a nice solution. You can also, for example, use a bash script for that. But what I prefer is to use Terraform built-in functions, and there are a lot of them. So, for example, when you have a feature branch name which is 100 characters long, there's a Terraform built-in function substring, where you can just take a substring out of this feature branch and then can only add this substring to the end of this specific resource. And or when you only want to use lowercase letters, there's this built-in function lower, which translate all uppercase letters to lowercase ones. And there's also a replace function where you can do basically everything, because you can use regex there, find a specific string and replace it with another string. Okay, let's have a look on the pipeline integration. Here we are using Azure DevOps, and that's a snippet out of this pipeline description. So we can see here the trigger when the creation of this feature environment gets triggered. We can see in this line that it will be triggered when the name of the feature branch is either master, which is the default branch in this case, or it starts with feature and then slash and a wildcard. And in this case, and with this way, you can also, in this way, only a feature environment gets created, a copy of your environment when the feature branch starts with feature, because you don't want, in any case, to create a whole infrastructure for any change. You know, when you just have a simply change, for example, you have a typo in your README file, you don't want to create a whole infrastructure for that. You know, this way you can do this change. And here you can see how the infrastructure is then automatically created after this one is triggered, after you created this one. So you can see here in line 13 that the workspace name, the Terraform workspace name, which we also saw before, is directly related to the current branch name we are working on. And then with this comment, I cut off the feature prefix. And then, so this is then we have stored here the workspace name of this variable. And when we look at the script, at the steps of the script, we can see here that, yes, we first perform this Terraform init. And in this line, we can see exactly the switch of our workspace. So we will select the workspace if it's already existing, or we create a new workspace with exactly this name and working on that. And after that, we apply the resources. We perform an apply, which we also do in the hands-on to apply our resources. And this way it is automatically created. And here we can see that's the web interface from Azure DevOps. Here we can see on the pipeline some of the pipeline executions with multiple stages. What I showed you before, it was just a snippet, so not the whole pipeline. So we can also have here multiple stages and perform some tests and so on. And yes, in this way, it will be triggered. And now we can have a look on a specific pipeline on the database step here. For example, here a database will be created, and this is the apply step of the database creation. Here we can see that yes, a database is created, but I've also said it as a disadvantage, especially databases. For the database, it takes a while, 6 minutes in this case, to spin everything up, and then yes, our resources gets created for a specific feature branch, and we also can automatically destroy the whole feature environment after we are done with a specific feature and merged it into the main branch, or we have not merged it into the main branch. Then we can also create here Azure with Azure DevOps in this case a pipeline which destroys our database, also the database in this case, and yes, destroy everything. Now I want to say thank you to WeAreDevelopers and also to the audience which listened to me. And I also want to highlight that that Deloitte have job offers. And so when you're thinking, cool, I also want to do something like this in my job next, please apply for our jobs. And yes, that was all. Thanks.
Hello again, Thomas. Thanks for the awesome talk.
Thanks.
So, but I hope you have some knowledge left because we got some questions. Are you ready?
Yes.
So, first one would be, what is your opinion about the Kubernetes because it is open source and can manage apps across multiple hosts?
My opinion about that, I'm currently also doing a certification in Kubernetes. So, and that's also a thing which Deloitte supports to do certification for different services like Kubernetes or AWS Terraform. So I'm also like to use solutions like Kubernetes.
All right, next question. Can you comment, please, Terraform features like scaling and self-healing?
Yes, to scale, the scaling to create more infrastructure. To scale the infrastructure, you have described before with Terraform and self-healing. So when Terraform will check the resources that you have created, and then it will check the current state of your infrastructure and compare it with the state file you have created, and then it will, yes, and when there's a difference with the state file and the actual infrastructure, then it will self-heal that and get back to the state you want.
All right. Thanks for that as well. You already talked a bit about pros and cons in your talk, but there is a question, why is AWS a better choice than GCP and Azure? Maybe you have also some pros and cons there, why you use it?
Yes, for me, yes, I really specialized for AWS in my case, but we have also here in Deloitte we have also different, specialists for Azure or GCP, and I picked AWS because yes, because I think the market is it has the biggest piece of the market and the most projects, and I was especially interested in this cloud.
Okay. So thanks for that answer as well. We got some more questions. Where do you save your Terraform states? Directly in the Git?
Because in the hands-on, I've stored the state files in the state files I stored directly locally, So the configuration files you saw, you store the configuration files directly in Git, and the state files are stored in an S3 bucket with AWS, and there are so it depends where you store your state file. Depends on your provider which you are using. When you are using AWS, for example, you store the S3, you're storing the state files in an S3 bucket, where you can, and then you can also share those state files with different developers. And the state files are not longer on your local machine.
All right, makes sense.
Yes.
So next question. Can I modify the Terraform code, like add a resource, for example, and apply it to a specific workspace?
Yes, you can also do that. Yes.
Okay.
So yes, and, yes, that's exactly that what you want. You switch. You are working on a Git branch. Then yes, then you create a feature branch out of your main branch, and then you modify the code on this feature branch there, and then you can apply the resources direct to this feature environment for the specific feature branch.
Okay. Next question. Do you use Terraform with Ansible? Is it working well if you do so?
Currently, I'm not using this now. Sorry.
Okay. Short and simple. Next question. We are using different infrastructures for environments, dev, test, prod. When do you recommend feature environments?
Especially for the development. For the development environment, because the best practice when you have something like prod, dev, or QA, different environments, you split this in AWS. Because I will stay for the AWS, you split this with a different AWS accounts. So there's a feature which is called an AWS organizations, where you can manage different AWS accounts, and for every account you are creating your own environment, for dev, for QA, for prod. But when you want to work with feature environments, just in the development process, you can only use one account for that.
Right, thanks for that answer as well. Some questions left. Are the built-in functions in Terraform same as string functions in SQL?
I think they are quite same or not. I don't know if they are the exact same. I don't know that.
Okay.
But they are quite similar.
Maybe a question for Google.
Yes.
So, next question. What are the main advantages of AIC, infrastructure as code?
There are a bunch of them, and I think you have already saw this or not.
Yeah,
during my
I
one. You can create, you can describe your resources in code, and then you can store this code in Git. So you have. And you can also create those resources, and you can also destroy these resources, make changes to them. And let's imagine you don't have this. you don't using infrastructure as a code tool. You just have this AWS console web page, for example, and just click every time you want to create a database, for example, have to click through the AWS console and have to create it by your own and do it manually. And this way, it saves so much time. In my example, it was only one string, but let's imagine you have a whole project, a whole infrastructure for a whole application. Yes, it's the best way to deal with that.
All right, thanks for explaining that. Next question. Is the automation in Terraform a main advantage?
Yes, of course. Automating everything, yes, of course. What especially mean by that? Automate in an automated way, create all the resources, and also destroy it. Yes, it's really an advantage.
Perfect. So next question: do you use Terraform Enterprise?
It depends on your project you are currently working on, but on yes, it depends on the project, but on my current project, not.
Okay, but casually, if the environment demands it, then you do it. All right. So, Thomas, you told us that your company Deloitte is looking for some new hires. Maybe as a senior there, you have to share some more like insights on your work there, things like that.
Yes, and I can do this. And that depends also on the project you're working on and on the phase of your project, But in general, it's really talk with your team and also talk with other teams about current, yes, let's be abstract, current problems or current features you want to implement. Yes, this is really a big part of your job. Talk with people about problems and what's the best way to implement this. And then you have also daily meetings for this and yes, implement this. But also a big part of my job is to really implement this, the features we have talked about. And yes, that's why Deloitte as a consulting, yes, maybe is only known as this consulting firm, but yes, you can also do a lot of development there, which is nice.
So if that sounded interesting to the audience, maybe you can go to WeAreDevelopers.com. We listed some of the jobs from Deloitte there, so you can apply just over this platform. All right, Thomas, thank you so much for the fascinating talk and also the insights and the Q&A. I hope you have a nice day and see you soon. Bye.
Thank you. You the same. Bye.
All right, quick reminder. If you are also as hyped as me for the upcoming WeAreDevelopers World Congress 2023, go to wearedevelopers.dev to pre-register and to get a discount code for your purchase. And before we jump to the next speaker, we'll have a short break of about 10 minutes. Stay tuned.
found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back everyone to the live day. Before we go on to our second speaker, quick reminder, if you're watching this on YouTube, just follow the link in the video description to join us on our platform, because there you can chat with the others and maybe also submit your questions if you have some, that is. And now to the second speaker of today. His passion lies not only with testing, but also the open source community. And to earn his keep, he provides training and consulting to government departments, private enterprises, and charities. Welcome, Chris.
Hi, thanks for having me.
Hi, Chris. Wonderful that you're here. How are you doing today?
Good. Excited about this, and thanks for having me.
Awesome. So maybe you want to introduce us a bit to your topic, what we are going to learn from you?
I'll be kind of talking about the super sexy topic of policy and governance, and doing that at scale and trying to run that as a day two operational space. We should hopefully kind of learn some tools and practices and realize the things that we've not done that we do elsewhere that we could reapply ultimately in this space.
Okay. I'm sure it will be a gripping talk, Chris. And I would say without further ado, stage is yours.
Thanks a lot. Hello. Well, imagine a thing is live and I get to actually kind of use a clicker and things. This is very exciting. It's terrific to be here. Please do leave a comment in the chat. It'd be great to kind of hear where you're all joining from as well. That'd be great. So, as I said, elephant in the room, policy is a dull thing. It's kind of hard to make it sexy, but I'm going to at least try and get your attention. So, bear with me. So to set the scene, I'm in a lift. Yes, American friends, if you're with us, we do really call them lifts. And 4 people walk in. I think to myself, Chris, this is your moment, now or never. As the door closes and I position myself in front of them, a captive audience, they're mine. I've got them. I hear the doors seal shut behind me and I take a breath. I look to the first person on my left. She's in a suit. She looks really important. I gesture to her. See? She looks back at me as if to say, yes, go on. She nods. Oh, perfect. The CIO, the policymaker, the one whose neck is on the block. What are the chances of finding you in my imaginary lift today? I ask her, what keeps you up at night? Well, she tells me, I don't know what teams are really doing, what the volume of risk, and what I should be showing more interest in. Setting and changing policy is slow, hard to communicate, and people just go off and do their own thing. They think they know better, and to be honest, often they do, but then I'm left playing catch up with the risk that they've signed me up to. Okay, I say, try not to sound like a patronizing snake oil salesman. I can help. I turn my attention to the second person in a suit. They look slightly less important. I make a guess. Let's face it, this is my imagination. It'd be weird if I was wrong. Product manager, I say. They nod. The whip cracker, I say. Well, what's important to you? Managing risk. So mostly opportunity risk, the fear of missing out. So getting features out the door and avoiding getting bogged down with, as they glance to the CIO, bureaucracy that seems designed to slow me down. Awesome, I say. This is your lucky day. I turn to the next person, dressed in overalls. I'm in a trendy part of town. They could be the CTO. Before I ask, they sense me staring at them. Cleaner, they say. How did you get in my imagination? Okay, I'll come back to you. My attention goes to the last person. Hoodie, headphones around their neck. My stereotypical developer. Yes, I know you well. What code do you write? I ask. Well, it doesn't really matter. Python. Cool. Have you got everything updated to work with? I pause. Python 3, they offer me. Yes, Python 3. That must be hard. They don't know it yet, but I've kind of superficially won some of their trust, which is important, as we know. Nearly, they say. Cool. Well, what's important to you? Staying on top of kind of patching dependencies so we can react to the next fire, knowing what rules exist, what ones I can bend, break, and ultimately what might cause me to lose my job. writing consistent, good quality code and avoiding technical debt, so the rest of my team all being able to cohesively operate and work as one. Do you use any tools to help you with that, I ask? So yeah, linters, code quality, test coverage, the usual kit and caboodle. Great, I say. Well, let's be friends. And I hand them a printed QR code and say, here's my public GPG key. So you know that you can trust what I say. I return my focus to the cleaner. I've got it. How do you get told what to do and when it changes? Well, we get a memo or maybe something stuck to a notice board. Last week, we got a memo saying that all the meeting room whiteboards needed to be cleaned every night. Interesting, I say. How does that work out? Well, it's up to us to then maintain that to-do list so that we can onboard new people. Does it go wrong at all? Yeah, so sometimes if we compile that operational manual, we might miss a memo or don't apply them in sequence and we get things wrong. They glance apologetically to the product manager, like when we hadn't updated the guide that the meeting room on the 3rd floor was being used as a dedicated war room, and we wiped all their boards down. I look to the dev. Does that sound familiar? I ask. They nod. Well, turns out we're not all special snowflakes, eh? All is not lost. I knew that there was a reason that I imagined you here today. The lift is slowing. I feel it coming to its destination. Great, I've got the silver bullet for you too. The CIO looks to me, ready to buy whatever it is that I'm selling. They ask me as the doors open, well, who are you and what team are you in? As I move out the way to stop obstructing it, I answer, I don't work here. I'm just here to fix the lift. People have been complaining that it only goes to the top floor, no matter what button they push, and it's actually pretty slow. My audience storms out, furious, heading towards the stairs, and the door's shut. I get back to my job. So if any of that may sound familiar to you and you can relate to my kind of imaginary friends, then I may have some answers for you. What if I said you could update policy easily, with even releasing several version updates, not just in a year, a month? What about 10 updates in a single day, and seamlessly communicate those to the people that need to consume it, all without derailing them? You can have visibility on compliance tools using tools that you already use. And that policy could be readily consumable, easy to pass, and demonstrate compliance. Make sense and ultimately not be bureaucratic to change when it needs to be and not get in the way. That same policy could be treated as a dependency and operate like a linter, so you can run compliance checks locally in CI and then guard production. That multiple versions of policy like a dependency are supported. So emergencies like you must update now because there's some known vulnerability type updates are a business as usual activity to communicate. Does it sound interesting? Okay, hang around. Doing about all right for time. So now I've at least hopefully got some of your attention. It's time to introduce myself and start explaining things. So my name is Chris Nesbitt-Smith. I'm an instructor for LearnK8 and also for Control Plane, consultant currently to the Crown Prosecution Service, which is part of UK government. And I've spent a fair chunk of my professional career now working in UK Gov and large organisations where problems like these are rife. I've been promised we'll have some time at the end for questions and your best heckles. So if not, come and find me on LinkedIn or something afterwards. So while this is it's live but not in person, where I would normally kind of ask for a raise of hands, we can still have some audience participation. So if you could leave me a comment of policymaker if you're with my CIO and have set, written or applied some policy before. Let's see if anyone's going to play. So if you set, written or applied some policy before, it'd be great to kind of see, get some feedback from you. Maybe, or maybe I'm not seeing the feed of chat. I presume that someone's answered. So great, next round. If you've ever sought exemption or maybe consciously bent, broken, circumvented, ignored, bypassed, whatever a policy with at least good intentions, could you leave me a comment of policy breaker in the chat? Perhaps the comments aren't coming through to StreamYard. Never mind. Well, if you've responded, you fell for it. So thanks to the organizer as WeAreDevelopers, we've got all your names and your employer's details recorded and captured. So kind of put your phones down, lend me your ears, that the stakes just got raised. So where do I see policy as code going wrong? Well, before we dig into that, what do I mean by policy? So it usually comes in one of two forms. So security enforcing, like say data at rest being encrypted, or consistency enforcing, such as code style, say maybe tabs being 2 or 4 space indentated maybe. Or maybe you can think of some others, but in any case, it's hopefully intended to mitigate a risk of some sort. However, with the best of intentions, these are often emotionally led rather than being grounded in proportionate control, which consequently becomes the open door to case-by-case exemptions being required when you come up against a situation that you weren't expecting. So this is not unlike fundamentally how the laws of the land are created, with case law making for a complex to navigate rulebook and harder still to then measure compliance. It often looks like the thin end of a wedge where the precedent, which may have been an uncomfortable pill to swallow the first time round, becomes dangerous with others looking to expand upon its scope, which can lead us to sometimes wonder if the cure was worse than the disease. But that's not how we at least typically develop software. So why does this all have to be so hard? There surely must be a better answer. We've codified everything else, so isn't this the answer? Well, yes, in part, but my point of this talk is that we fundamentally do it wrong. So maybe some of you out there are screaming your favorite product name at me in your heads as the solution, and you're not wholly wrong. The devil is fundamentally, though, in the detail. Throwing some curly braces or YAML syntax around something doesn't inherently fix things. If it's a security control, it might be often tempting to keep that policy a secret. Exposing it could conceptually maybe be used against you by an adversary. However, that does not support us kind of shifting left and buzzwords. It results in devs effectively reverse engineering what that policy is by finding out when we smash our heads up against it. It doesn't therefore take much imagination that in a scenario such as an application deployment, you can find yourself midway through finding just one of your resources is now not compliant and will be rejected. And that could leave your overall deploy in an inconsistent halfway state and likely result in some downtime. Which begs the question of, was the policy better than the downtime? Especially if it leads our engineers, who are all hopefully plenty smart folk that we've hired, finding inventive, shall we say, ways around the computer says no response that they've received. So this is then further exacerbated when updates to the policy are desired. So maybe you get a pen test or something goes wrong, or so you form that case law that you need to apply a new policy. Maybe say all S3 buckets now need to be encrypted, a change that could well be considered breaking. Sure, you might say you provide some maybe warnings on at least the less important issues or new emerging policy, which is great, so long as someone sees them. But if you've adopted GitOps or at least CI/CD, is anyone actually seeing those warnings? Who is studying the results of a successful build log every time? Anyone? Every time? Well, if you are, I'd probably politely suggest that you're missing the point of CI/CD. You should ultimately be able to trust the Boolean kind of job status that you get at the end. Okay, so I'm not here today to just throw stones. If we remember kind of my implied promises to my 4 imaginary friends at the start of what this promised land might look like. Well, there's fundamentally nothing new under the sun. We've actually already unwittingly solved these problems elsewhere. We just need to be reminded and able to join the dots. Well, the first is, if you're doing policy as code, you may well already be doing, which is put it in version control. The thing that you might not be doing, however, is then making that visible. So at least in a source set, by which I mean allow anyone within your walled garden of employees, suppliers, or whoever to see the policy. I'm not saying give all your threat monitoring rules and intel away. You can probably keep that to yourself. But I would argue that the visible policy and the gaps therein is often better than the downtime and reverse engineered workarounds and the opaque legacy exemption spaghetti soup that will arise. If you're brave, you might even open source it. You'll find it unlocks an ability to work well with prospective suppliers without NDAs and whatnot. And widely distributed secrets are expensive to maintain, difficult to handle, and often only stay secret for so long after all. Okay, so we're off to a good start. Our policy is visible now to those that need to see it. many of you in this community are no doubt used to semantic versioning, but a quick recap in context to this. So the first segment is to use to indicate breaking, perhaps conflicting changes. So in the context of policy, let's say it's requiring resources to say have a department label. Maybe that will help with some internal cross-charging. Who knows, I'm not judging. And increments that might look like requiring that to be from a predetermined list rather than just free text. The second segment is to indicate minor changes. So these shouldn't break anyone. And increments that look like, say, maybe correcting a spelling mistake on one of the department names. The third segment is an indicator patch changes. So these should be a no-brainer to keep up with. And increments that might look like adding a department to the available options, perhaps. Okay, so our policy is visible in a repository, its versions, so we can easily communicate that policy. We can tack on release notes, and expectations are all being managed by semantic versioning. In software, we're used to handling dependencies. So what if your policy was just another dependency? So you might unwittingly already be doing this if, for example, you say have ESLint as a dependency in your JavaScript package, perhaps. Okay, so our policy is visible in a repository, it's versions, so we can easily communicate that. We can tack on release notes, expectations are all managed by Semver. It's beginning to look a bit more like software. Okay, I know testing is a dirty word, but in order to make this an asset that everyone can depend on and also provide kind of known good examples, tests are essential to give everyone confidence in the stability and surface the potential side effects before they ultimately hurt everyone involved. Consumers of this policy need to be able to test themselves against the policy locally and in CI/CD, thus shortening that feedback loop and better informing. So as a bonus, we should be able to find our consumers able to rely on the artifact that we're sharing with them. Okay, we're well and truly on the home stretch. This is a dependency, so updating it should be fundamentally no different to any other. We can even use some magic like GitHub's Dependable or Men's Renovate to do that for us. So think automatic pull request tests, even auto-merging if you like. Okay, so to check you're all still awake, hopefully, if someone can chime in, can someone put in the chat a recent event that caused everyone to want to know what version of a certain logging Java doohickey you were potentially running literally everywhere in the estate? Yes, as you know, all presentations this year are contractually required by the organisers to reference log4j, even when it's almost entirely out of context, and include some memes. In just a few short months, I can remove these and hopefully just point broadly at a list of scary-looking CVEs in order to command your behaviour through fear. What I'm getting at here, though, is that the situational awareness piece of the software supply chain is something that your organization is hopefully already thinking about, if not already addressing. So if our policy is a dependency, this at least is not a new problem. So software bill of materials for the win, right? Which can allow us to then measure the compliance across the estate. Okay, so I've just covered a lot of ground and hopefully sounded at least vaguely convincing. And it's not just a fictional utopia painted in PowerPoint. It's time to look at how we might be able to actually do this. And I know you all came here wanting to see a million words on a slide and not just the odd emoji or two. So we've reached the point where I get to show you some code. Hooray! But to maintain some scope, I'm going to limit this to talking about two things to prove that it's not just one tech or one tool. I've arbitrarily picked Terraform and Kubernetes, but I could have fundamentally picked anything. Naturally, I'll need some tools to go along with this. I'm too lazy to invent anything new here. So likewise, I'm going to pick two tools, but again, I could use any or some or even all probably. So in this case, Chekhov is going to be doing my Terraform and Caverno is going to be doing my Kubernetes. If you want to browse along with me, I've created an example GitHub organization here. I'm not expecting you to read or grok the code on the screen necessarily, so don't worry about it too much. It's just to prove that there's a real thing that exists somewhere. So the policy is stored here. So here's where my policy starts at version 1.00. I've got policy that requires this department label on all resources. So long as it's set, doesn't matter what it is. I've written tests for this, so you can note how those passing test cases are usable as a great example of what good and bad looks like. We pushed a tag in Git, we've added release notes, and I can sign it to provide further assurance if my heart so desires, which of course it does, obviously. But moving on, version 2.00 looks similar, only now that department field has to be one of a predetermined list. So, like before, tests exist, release notes are written, tags are signed. 2.1.0 is where we notice and correct a spelling mistake of one of the options in that list of departments. And 2.1, we've now just added a new department to the list. Few more repositories in that organization. So there's app1 and infra1. So these depend on version 1.00 of the policy. It's not compliant with version 2 or beyond. But how do I know that? Well, I've configured Renovate in this case to automatically make me a pull request. So when there's a new version of the policy, it's super obvious if I can update that dependency. And I can see clear feedback about where and why I'm not compliant. I can also see all the pull requests over my org, so I can measure the compliance of my policy. Moving on from that, a few more repos, app2 and infra2. Well, these depend on version 2.00 of the policy. However, we could merge the open pull request all the way up to 2.1.1. And finally, app3 and infra3. Well, they are dependent on 2.1.1, and they get a gold star from the CIO. There is a small touch of magic, and it's not pretty, though. I've written some bash. Don't judge me, even though I probably will definitely written worse. What this does, though, is it allows me from my dev laptop or in CI to evaluate my code against the version of the policy. So ideally, this might be less cumbersome, but it is what it is for now. Pull requests are all very welcome. And the last piece of the puzzle is managing the life cycle of the policies and allowing multiple versions of that policy to be accepted and evaluated within a single runtime. I've cheated a bit here. Kubernetes gives you admission controllers. It's not so easy to get that same localized policy evaluation from a cloud vendor. They've got their own kind of policy as code, and I've not figured out how to be able to evaluate that locally. Again, pull requests, contribution, collaboration, all very welcome in this space. So you may have noticed the way policy is designed, the policy was designed and distributed lends itself well to coexist with itself and other parallel versions within a Kubernetes cluster. Which brings us to cluster 1, another repo, which describes a cluster that accepts all of the versions of the policy that we've described so far. Likewise, cluster 2 exists, but that only accepts version 2.00 and greater. So we can automate this to proof of concept using kind and some CI to deploy all the apps. And there we have it. Well, a full org, all done, all compliant, policy, all versions, CIO, all aware of what's going on. So this is great, right? But just one more thing. Wouldn't it be awesome if the policy carried a story of why it exists? After all, if your agile team is even half effective, it will naturally reject anything that it perceives as friction if it doesn't see the value in it. It could allow our devs to know, say, why they're compliant. And if they want to do something outside of what the policy permits, they don't need any sort of exemption granted per se. They can have a well-reasoned and informed debate with rationale behind a pull request to the policy. So imagine, if you will, this going through a stage of versions with risks that inform the mitigations and that become manifested as the policy, all maintained as one. So when the risk landscape changes, your policies can then move with it. So when some new privacy regulation comes out, for example, or your latest marketing strategy pays off and you acquire more data, for example, even if your policy was perfect at one time, the risk and the appetite for it will stand still for no one. We can liken this to over-provisioning that we might be familiar with elsewhere, where lead times are long, change is hard, and there is a significant pressure in nailing it the first time, which can lead us to hedging bets against what some future state might be, rather than proportionate mitigation to the risks that are more tangibly in the real now. And that's where the real culture change is fundamentally needed, and the execution of that is likely a long series of talks in of itself. So for now, it's all over to you. Honestly, the best thing that you could do right now is tell me this is madness, already done, irrelevant, or otherwise unachievable. Something my esteemed echo chamber appears are yet to do. So beyond making pull requests and developing the theory more, I'd really like to start building a case study with some more willing organizations and allow me to swap out my imaginary friends for some real ones. But the most important thing that I want you to kind of remember and take away from our time together today is that, and please feel free wherever you are to say this out loud with me. Purposeless policy is potentially practically pointless policy, which I've been practicing saying far too many times. So I've been Chris Nesbitt-Smith. Thank you so much for your time. You're now free to leave, or obviously stay on for the rest of the talks, but go grab a coffee or something. Like, subscribe, whatever the kids these days do on LinkedIn and GitHub, whatever. You can be rest assured that there'll be little kind of no spam, much content at all, really, since I'm awful at any sort of self-promotion, especially on social media. CNS.me just points to my LinkedIn, and talks.cns.me contains this and other talks, and they're all open source. So questions are very welcome on this or anything else. I'll be hanging around in the comments section for a while, or ping me a message on LinkedIn out of band. And thank you very much for having me.
Hello again, Chris. Thanks for the presentation. Chris, do you hear me?
Yeah. Sorry.
Hey.
Yeah.
Very light-hearted slides. I love them.
Cool. Thanks.
So, all right, we got some questions for you, if you are ready.
Yeah, absolutely. So they didn't come through on the thing.
So, if devs are trying to circumvent policy, isn't this basically a cultural problem that requires dedication and better communication from policymakers?
Yeah. All round, and that's part like the thesis of the piece is that this is not a code. Like, you can't just throw a like some YAML or some like curly braces at it and like, here's some code. You see the same thing of like companies that go, I bought Jira, therefore we are agile. It's like, well, no, the same premise exists. The whole point is that this is far more a philosophical, cultural challenge, far more so than like a technical solution. The point of this ultimately is that by policymakers articulating the reason why in a tangible means, then it becomes much easier. So if you have the data and things like that are hard, right? If it's a physical asset, like whatever the current currency is, like an 80-inch TV in a house, well, you kind of go, I'll probably put a lock on the door. I'll probably put some double glazed windows in. I may have an alarm because I've got like a laptop and some other things. And it's a tangible thing where you can go, yeah, physical asset I can see. But spending kind of it's easy for anyone to grok that as a thing and follow it. You go, well, cool, that is proportionate mitigation. However, when it's getting in the way of what you're trying to do and it doesn't feel like a tangible thing, then culturally it becomes the problem that folk don't easily recognize and articulate it, and policy being set emotionally rather than just based on some proportionate control is the cause of that ultimately.
Right. Thanks for that answer, Chris. We got another question. What do you think about cheaper cloud providers like Linode, for example?
Yeah,
if you're
cool. It's not I guess in context to policy, but I did say any questions on anything are welcome. So it all like depends on like your risk tolerance and things like that. Ultimately, like, it's generally encouraged you to actually understand the risks that you've signed up to, if that's going for a small outfit or like a mum and pup shop, or it's going for an enormous kind of multinational kind of international conglomerate like AWS. Like, it's that operate at a different scale. There's a difference in terms, like, from a risk kind of landscape and also from features of like embrace all of the kind of the services from any of those vendors. Don't try and do things yourself, I guess, ultimately.
Right. Next questions. What are the security policies in the cloud at the level of the database and the database cell?
What, as a runtime thing, I guess that question kind of talks to. So it all depends on your technology, right? So and you can imply and apply that sort of policy in a whole heap of different ways. Like, you can do that depending on what the technology is, but you can do obviously row and cell level encryption and how you would then pick up the keys. But it all depends on the technology. Like I'd ultimately go and use a managed kind of database instance from somewhere else. Don't try and build your own encryption algorithm. If that's a thing that you care about, but again, like it's a proportionate control, and you need to take with that like the complexity, the performance impact that will be, your ability to recover from a crisis. Like if things go wrong, data being encrypted makes that hard to recover from. And the biggest key ultimately is how you handle key material, like your private keys, the things that are actually going to decrypt that. Well, where are you keeping those? And if they're always hot, like question mark over whether the value in doing that row level encryption, or even kind of field level, kind of cell level encryption, if the correct keys are always running somewhere, then it doesn't gain you anything. And also kind of how you've your sharding of key material and things like that as well.
Okay, thank you, Chris. Oh, another one, liked your presentation style. Thanks, loved the animation at the start. What tools were used for the creation?
For the presentation, it's all HTML and all open source. So you can go check it out. There's talks.cns.me contains this and other talks. And they are all open source. So github.com/chrisns/talks. If you're interested in the code behind it, uses MARP, which allows me to very easily. I don't like PowerPoint in terms of kind of how I present. As you've seen, like there are 163 slides that I rattled through in about 23 minutes. It's in order to do that and run it as a narrative, PowerPoint doesn't work for me, so I write everything as Markdown. Because that's how I work. So yeah, it's all in that, and the code's there if you're interested in it.
Okay, thanks. Another more topic-related question. Can you tell what you think about policy like RBAC, OPA, etc.?
I mean, I'm not a big fan of Rego. It hurts my head. I mean, it's optimized for so Rego is what ultimately sits behind OPA. Like writing it as a developer hurts. My head does not handle double negative, kind of that complex Boolean logic well. It's optimized for performance, not for kind of human readability, which is fine. Like you can accept that that's the thing. But it does mean that your footprint in that becomes it's complex, and the bigger payload of policy that you have, the more difficult that gets to have in your head cognitively to actually be able to pass it. Like it's nice to be able to evaluate like the policy within your head rather than before you actually kind of hit run to see what actually runs. So I'd say like the key ultimately is make sure like your development experience of that policy, whatever tool you use, is good. I mean, for this talk, I did do other permutations of it using kind of OPA with Gatekeeper and things like that. It's much for muchness. Ultimately, I pick the tools that you kind of understand and know, and make sure that like the experience of writing and maintaining that policy is good. Like it's some code, so treat it properly. Write some tests. So don't just shove some Rego into a YAML file and hope for the best. And then like test it in live effectively. Like write some Rego, and if you're doing OPA or whatever, and have test cases for and get like happy and unhappy paths to each scenario. On OPA, I did write on my GitHub. There's a OPA boilerplate which includes like some like structure. So I did it for my own sanity, of how you can like write the test cases for it and then embed that into your into Kubernetes, or you can apply obviously OPA like pretty much anywhere these days. But yeah, like fundamentally it's code. So treat it like we do other code as professional kind of developers that have some pride in our craft. and write some tests, maybe version it, and all the other things, good things that we should be doing with code.
Right, thank you, Chris. We got another question. How to detect and mitigate supply chain attacks? Take your time thinking, it's okay. Stay hydrated.
Yeah, accept defeat. No. Ultimately, it's risk, right? And there are proportionate controls. You can go down the line if you are like Google scale, where they fork pretty much every dependency that they rely on and then maintain it and stuff themselves, and can actually have the resource to go and read every single line. There's a brilliant XKCD comic of the very kind of low down bit. I'm never going to be able to find it quick enough to show it, but kind of points at like all of this stuff that we build on top, and then somewhere down the line there is a small dependency that's maintained by an individual in Nebraska somewhere that kind of does it in their spare time, and it's just looked after by one person. And the whole world kind of ends up landing on that. And we've seen obviously that with kind of Log4j, Heartbleed, with OpenSSL, and like so many others, and there will be so many more to come where we'll see this as a constant ongoing trend. Ultimately, it's like understand the risks and look to the advice that you get from like the bits of central government. Ultimately, it's patch, like make patching dead easy. The days where you could do like quarterly releases probably long past, especially on like this community of where we are today. At least, like that's hopefully not something that we are thinking is good, and strive towards your kind of very rapid delivery of things, and treating your hot fixes of a patch thing exactly the same as how you release a new feature. So it all gets tested and done in a pipeline all the way through. So to that end, use like obviously static analysis of tools like whatever, like Sneak, SonarQube, where Mend have got some products in that space, and kind of Renovate will actually just do dependency kind of updates and stuff, and make you proactive things. So things like as I've used on the repos on this talk is Renovate makes you an actionable thing. Like there's an update to a bit, makes you a pull request. Happy days, right? And the developers can see that it doesn't break their tests because hopefully they've got enough test coverage. Therefore, they can update the dependency. And if you're doing that and you've got the pipeline to get it through to production quickly, then everyone's happy. And that's ideally where I'd hope as an industry where we're getting to.
Yeah, let's hope so. We got maybe a bit more general question. What about sandboxing? Can you tell more?
More context probably needed. I guess like on a kernel level, or like maybe if they can
maybe David, you want to specify the question a bit so Chris can answer it. In the meantime, we had one question in the chat. I think it was more for the chat, but David also asked what club in the Premier League Chris likes the most. Maybe you can elaborate on this in the meantime.
Say it again. What? Sorry.
What club in the Premier League you like the most?
Oh God, I can't. I don't follow football at all, I'm afraid. Okay. Sorry, but I couldn't possibly comment.
All right. Well, apart from that, you do consulting and trading also for governments and for companies. Maybe you can give some insights in this kind of work, what you're doing the whole day.
I mean, most of my world is like I don't get to write code, I guess, but certainly not in my normal job anymore, at least. So my world normally looks like brokering risk conversations between like some doers and some risk owners, and explaining the consequences either way, and try and bring that together so that the doers can understand and have a more tangible thing. Obviously, working in kind of government, there are like safety critical systems that keep people safe when leak data, and there are kind of real, tangible, real world consequences that happen that would be horrific stuff that you wouldn't want to kind of carry on your shoulders as a responsible engineer. So it's figuring the ways of how you can articulate that well enough and provide proportionate mitigations. Like obviously you can take a data set and kind of go, cool, I will now soak it in epoxy, wrap it up in concrete, and then dump it to the bottom of the sea. And that is the most secure that can be. No one can get to it. Awesome. Integrity, perfectly managed. However, it is in no way available to actually do any queries against or use or consume. So there's always a balance to be struck somewhere between those bits of actually kind of how you're able to consume it. Like secure isn't a thing, right? It's secure enough and proportionately enough for the risks and for the concerns that you're trying to address. And that's kind of mostly where my world is, of kind of say like bridge the bit between some business and some tech and go, actually you're talking about the same problems. Like your people, your developers that care about things like using linting tools or something so that their code at least has some consistency with the next developer, or even the same one 5 lines apart or a day apart from writing it. Like that just having some just basic hygiene and consistency is fundamentally the same goal and thing that folk are striving towards in the kind of overarching kind of the grown-ups that deal with bits of policy and governance, and they're the ones that would have to stand up at a kind of ministry if something went horrifically wrong. They're the ones that's going to get called into kind of parliament to explain what the hell went on and why, right? So and naturally they're going to be risk averse, but it's not risk averse means kind of seeking out those risks, and that's the big key. You can't say that you're a risk averse organization if you don't actively try and find them. So yeah, that's ultimately kind of a lot of my world of kind of articulate and record, or try and capture where those things are and make them make sense, to like find bits of common language to explain that between them.
So all in all, a never-ending story.
Yeah.
So,
yeah.
We got the
better.
sandboxing question specified.
Yeah.
He means, what are the risks of sandboxing? Privileged sandboxes.
Privileged sandbox. So I guess that means using like something like a Linux namespaces and what seccomp or something like as a policy thing. Yeah, you can do that. I mean, it's all a trade-off, right? Your spectrum of choice between like physical machines, all individually separated, and air-gapped and all the rest of it, and you can do all sorts of fancy things with some color-coded wires and all that jazz that we used to do way back when. So you can do that as one extreme, or you're kind of further like the other side of it. You can do like full-on serverless, where everything you're running again in the same kind of kernel space as many other vendors. The cloud vendors are mostly kind of got better at doing that, but so they're not necessarily sharing kernel. But my point is there is a spectrum of choice, and it's all about like pick a proportionate control that is in somewhere in that spectrum that is within your cost appetite and risk appetite. Maybe quantify your risk so that becomes one thing, so you can point at a balance sheet and go, that's why I'm doing that thing, because the finance and the money makes sense to do that, right? But yeah, it's like it's vulnerabilities have been found in those things over time, right? So, but in all of those things, you've got some fascinating technology that comes around people doing kind of data exfiltration by looking at like flashing LEDs on a hard disk, or the noise that it's making, or the reflected light off the screen in an air-gapped office building that they've managed to capture with a drone videoing the wall again behind the person. Like there's that side of things, or you've got like people managing to pop the hypervisor and pop out of say VMware and pop up onto the ESX host. That exists. normally kind of Kubernetes, you can pop up to the host and then to the cluster just the same there. It's all the problems in different guises, different scopes, and different levels of maturity, and it's all ultimately kind of boils down to risk. There's nothing that's safe, right? None of it's actually good or safe. I think you could actually kind of wholeheartedly kind of go, yep, I'll put everything in one thing. It's a proportionate control that makes sense to what the problem is. But yeah, like to the actual original bit, like question around sandboxing. Yeah, there's plenty of bits of like gubbins of technology that will implement it for you. But is that right for you? Is that enough? That's a problem for your business, for your risk owners to make a decision on. There's no one size kind of fits all for that.
Okay, thanks for clarifying that. You gave us a lot of insights, a lot of information, but as it's such a wide topic, maybe do you have some go-to resources, some further resources that you can share with me and the audience for future research?
Yeah, so there's some other bits on my GitHub. There's some other similar bits of talks and similar bits of space. There's some blogs that I've written, but in terms of like currency of what's in the industry, the reason behind me kind of running around doing this talk is from an engineering kind of software development point of view. Like I'm still passionately sit up until 3-4 in the morning regularly and write some code. It's that trail of thought, but there's plenty of bits of kind of resource in terms of staying current. But yeah, the reason for doing these talks is fundamentally not seeing particularly versioning and the articulation of why you care about policy actually landing in organization. So it's a try and preach, try and like make something happen outside of my immediate horizon of what I'm able to kind of influence in my kind of being a singleton consultant. And operating in that way, like I can influence an organization at a time. The aspiration of this is to try and steer a wider community, or be told I'm wrong. Like that would be awesome. Like tell me I'm an idiot, and that'd be great too. In fact, I'd rather that. I can get some rest and stop doing these. That would be lovely. So yeah, like anyone watching, please do like articulate why this is an awful idea, and I would be really happy to receive that.
Yeah, I wouldn't dare doing it, but to the audience, you got his socials. Feel free.
Yeah, I'm awful at it, but yeah, find me on it and heckle. It's fine. And as I say, like, I would very much appreciate being told to stop. I can go do something else. It's fine.
All right, Chris. Thank you so much for all the shared information today and for the awesome talk. Wish you a nice rest of the day and till next time. Bye.
Cool. Thanks to everyone. Cheers.
All right. I have 2 giveaways. One for a Meter 2 Quest headset together with Deloitte. Just scroll down to sign up and you're good to go. And second, one of these rubber ducks, but with the plus of signed by Hawk and William Lee. For that, just subscribe to our Dev Digest newsletter. And before we go on to our third speaker of the day, we'll have a break of about 13 minutes. Stay tuned.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back, everyone. Quick reminder for the peeps who might join us on YouTube, just click the link in the description so you can join our platform, because there you can chat and you can submit questions. And now on to the third speaker of the day. She's Senior DevOps Engineer at Wix.com, and she provides the vocals in a cover band. Welcome, Hila, sorry. we specified that. I'm so sorry for butchering your name. Hila, you're muted. Wait a second. I can't unmute you.
I unmuted, all good.
Perfect. So, Hila, thanks for joining us. I hope you're doing fine.
Yeah, I'm doing great, and it's awesome to be part of WeAreDevelopers, so I'm excited to join.
Perfect. So maybe you want to specify a bit what we are going to learn from you?
Yeah, it's actually already incorporated in my talk, so I can just start and,
All right, then, Hila, stage is yours. See you.
Awesome, thank you. So let's see. Okay. So hi, everyone, and thank you so much for joining this session. And this talk will be about open source, and open source is open choice, right? So in this talk, I will give you a set of tools to help ease your decision about open source adoption, when you should do it, and practical tools that you can use to choose the right open source project for you. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. I've recently joined the AWS Community Builders Program. I help co-organize conferences in Israel, where I live, DevOps Days Tel Aviv, and Statcraft Monitoring Conference. I'm a mentor in courses and communities. I also co-manage a Facebook community with offline meetups about open source in Israel, but we try to be as global as we can. I'm a DevOps culture fan. I think this is what helps companies achieve great things. And I'm a lead singer in a cover band, as I mentioned also before. It is a lot of fun. You can see a picture here, and I enjoy it very much. Okay, so let's dive right in. Open source software is publicly available, right, and can be modified at will, but of course you open a PR and you don't just merge domain. And the thing is that a lot of tools that we use in our day-to-day is open source. So React, Java, Firefox, Linux, right? So a lot of tools that we already use are open source, which is awesome to know. So in the late 90s, proprietary software was considered the standard, and the notion of making source code public was considered bad strategy for tech companies. And coming forward to 2020 and up to until now, the concept of open source became more and more mainstream. So what's so good about open source? Open source helps build a rich developer community because it is a society that is based on knowledge, but really relies on the core values of communication and collaboration to succeed. And Manish Sharma, who's the general manager of GitHub India, he said basically that open source is an enabler for innovation, and that businesses that turn to open source, it helps speed up their business transformation. So we see that also in the upcoming years, that open source is more and more adopted in companies and by individuals. So let's talk about open source and why is it good, right? So open source really boosts our code quality and security because, as Linus Torvalds said, the creator of Git and Linux, he said that given enough eyeballs, all bugs are shallow. So since a lot of people can review code, because it's publicly available, then anyone can spot and correct errors and omissions. So if you don't only detect the issues, but also fix them, then the code will be in a much higher quality and secured, of course. And I want to share with you a bit about the open source community that I manage in Israel. It's called Pull Request, and we really try to incorporate and help people to contribute to open source as much as we can through workshops and stuff like that. And one of the initiatives that we have, that I lead in the community, is called Open Source Rel, so like DevRel, but for open source. And it's basically a way to showcase how companies perceive open source and how they actively contribute to this realm. So you can see that there are several companies that already featured in this initiative, my company Wix and other companies as well. If you want to showcase your company, you're more than welcome to reach out. In the end, I will have a slide with the contact details. And the thing why we did it is because we want to make sure that people know what companies are doing in this realm and how they actively contribute to open source, because that way, of course, it's a PR for the companies, but we're not doing it for that. We're doing it for, let's say I am a fan of open source, right? And I want the ability to know that if a company really believes in open source as well, maybe since we share the same values, maybe it will be good for me to work in that company. So in this way, we also think that we are able to boost open source adoption and activity in this realm. So that's why we do it, and we really hope that we will achieve this goal in the future even more. Back to route. So open source also boosts code quality and security, that, as we said, but also adaptivity. So why do I mean by that? Adaptivity means that we have more users, right, that use a certain open source project, which means more use cases, and then the code will be actually more robust. And the thing is that when it's adaptive to various use cases, it allows surfacing bugs and edge cases much more rapidly than traditional QA processes. And it also encourages more modularity, avoiding the one-size-fits-all assumption, resulting in greater flexibility and lower customization costs in the long run. Let's talk also about agility, right? So modern software development processes usually are followed in open source projects, which leads to rapid development cycles, which leads to more frequent releases without sacrificing quality. And we also have less bureaucracy, right? When you open a PR versus opening a commercial support ticket, it's a whole entirely thing. And there are no regularly scheduled release processes. So once we some release get out, it just get out and that's it, as opposed to a proprietary software where they have cycles that they need to follow. And I also put here some interesting read by Ben Balter from GitHub about open source adoption. I really encourage you to read it. It's very insightful. Okay, so let's talk about the DevOps perspective, right? So because usually open source is something that is more treated from the developer side and not the DevOps. So I wanted to share how we DevOps engineers perceive open source. But in order to understand that, let's cover first the developers aspect. So developers say, hey, we have functionality factors to consider. So will this code, will this library that I found, the open source one, get integrated in my code properly? And what efforts are needed to do so? As opposed to that, DevOps engineers, we have the environment factors to consider. So we look at that project and say, how and will it get integrated in my environment? And also we have other peripheral stuff to think about, like security and maintenance and stuff like that. Other than that, collaboration is a common ground between DevOps and open source. So every time I know that I have issues with some tool, I know that I can just open an issue and I have and I assume good faith, and I know that people will help me because we want to collaborate, we want to help each other. And another thing is that collaboration leads to better conclusions and solutions. And when communities form around shared challenges, then the diversity of ideas that naturally emerges surfaces better solutions. And we all want better solutions because, again, the focus that we have is the environment, and we want the environment to be as stable and secured as possible. And also we treat open source as tools, and we ask ourselves, do we want to introduce this tool to this system because it will help us to deliver code or automate this or introduce a certain capability? So we can really be flexible with what we introduce to our system because integration is no strange concept for us. Most of us, the DevOps engineers, came from the background of system admins or system engineers. So we have like a way of integrating stuff to our environments. So that's why we just consider it as another tool to our tool chain, and we can just integrate it, and that's that. But of course, not everything is good and just positive. We have other things to consider, and since our environment stability is the most important thing, we are in a constant state of trade-offs and maintaining balance, because we want to upgrade, right? Because maybe there are features that are good for our needs, but we don't want to rock the boat too much. And also the variety out there of projects is insane. There are a lot of things that are covered by open source projects, and we need to make sure that it is good and really suitable for our use case, but without rocking the boat too much. There are a lot of complexity as well, because if we take, for example, Jenkins, it has plugins, and show me one person that is able to upgrade Jenkins or its plugins without having any fear of anything getting break. So we have really stability considerations to think about. So that's why we don't really rush into things. We always need to make note of what's important right now and what is important to the environment stability as well as its functionality. And in the middle of everything is research. We want to read about projects online and how they are used, because we want to make sure we know exactly what we introduce to our environment. Another thing, this is generally true for DevOps in general, but also for open source as well. We need to keep tabs and be informed of what's going on, because I will give you 2 examples. Let's say I have a tool that I found, version 1.0 is not really right for the system. The features is not really what I need. Maybe there's even a very big bug that I can't afford myself to introduce to the system. So maybe I can just wait it out, keep tabs on this project, and then version 2.0 will be great for my use case, and the bug will get fixed by then and stuff like that. So this is one example. And another example is CentOS. It reached end of life at the end of 2021. If I wasn't aware of that, I'm putting my systems at risk, because what does it mean to have end of life? No security patches getting released. So if I don't know about that, then I'm putting my systems at risk, which is not good, because all I care about is the environment stability. So that's that. And I really like this picture because, as you can see, it says keep moving people, even though nobody is there. So that's exactly the mindset that needs to be incorporated in our day-to-day. We need to keep tabs and be informed of what's going on without having our team leader breathing down our necks and asking us to do it. We need to do it ourselves. I think it also will help us be better engineers. Okay, so I talked about the DevOps perspective. Let's talk on when should we consider adopting open source in our environments. So when we have an uncommon use case, I can show you a story from one of my previous companies. We had application installed on Kubernetes, and this application didn't need to run all the time. It could only run in certain conditions. And at that time, we used Google Cloud, and Google Cloud allowed to downscale pods only to 1 and not to 0. And that's why we searched for a solution online and found Keda. Keda is an open source tool which allows exactly that downscaling pods to 0 based on certain conditions. It was awesome. It was also declared as production ready, which is good for me as the maintainer of the environment. So this is an example. When you have an uncommon use case, you can just search online for an open source that will cover this use case. Another thing is limited budget. So when your budget is limited and you can't really afford purchasing an enterprise license of the software, then you can use its free version or an open source alternative. And it will also allow lower total cost of ownership, because adopting open source software generally has lower cost because the software itself usually comes at no cost or relatively low cost, and shifts the cost center from licensing to customization and implementation. And also, we need to think about the fact that training and maintenance and support will be equally invested in an open source project adoption versus proprietary software. So, might as well boost open source adoption if no significant reason is preventing you from doing so. The next thing is when you have insufficient in-house resources, ability-wise, like this family guy right here, or capacity-wise, to create a solution of your own or enhance a solution. So you can just find an open source tool that covers your use case perfectly or almost perfectly. And the thing is that there's a saying, why reinvent the wheel, right? If there's an open source tool that already covers your use case, might as well just use it, and that's that. Okay, so I talked about the advantages of open source. Let's talk about some disadvantages as well when adopting open source projects. So first of all, security by obscurity. This notion doesn't apply on open source because proprietary software companies can claim that their code is more secured than open source alternatives because of that principle. And then it's harder for hackers to exploit loopholes since the code is not available. So this is something to think about. Prone to abuse. So it doesn't happen quite a lot, but I only have two examples to give you. So the NPM package colors, where the maintainer added a loop in the code, is one of them. And another example is the Faker.js package where the maintainer had a bankruptcy, if I'm not mistaken, and then he released a version that basically deletes the project entirely. So it could happen, and you can just say, yeah, I can just put the version in requirements.txt or package.json log, and that's it. But I think that if every company will do it, we wouldn't even hear about these two issues in that scale because everyone will do it. And since we don't always do it, then it's still important to understand that it is prone to abuse. People like me and you are the ones who support open source projects. It's not always backed up by companies, so it is something to consider. Compliance. So in its raw form, open source usually gives no warranty or official guarantee, making it difficult to use in a business environment where compliance is a must. So it's also something to consider. Open source is not always free. We need to check the licenses carefully, especially if the reason why you choose this open source is because of a budget consideration. Discontinued projects. So as I said, not always the open source projects are backed up by companies. Sometimes they are backed up by people, individuals like me and you, and they can just decide they discontinue to support this project. So if you adopted this kind of project, it means that either you need to do a migration to another project or start maintaining this project yourself. So it's also something to consider. Support is not guaranteed. You should assume good faith, but as I mentioned, KEDA, once I started to use it and incorporate it in our environment, just before it was fully production, we had some issues. I opened an issue about it in the GitHub repository. I think it was Thursday night or Friday morning, something like that. And I didn't assume that they will do this for me because I have the deadline, not them. But I explained the situation and they were super nice and released the version for me with fixes for these issues. So it was awesome. So there is a need to assume good faith, but again, the collaboration is the foundation, one of the foundations of open source. So I can really think that you can assume good faith and it will work out. And the thing about proprietary software is that support is guaranteed, that you are guaranteed to get a support, but you're not guaranteed to have good support. So it's something to consider. And last but not least, SaaS alternatives. It's not really the opposite of open source, but on some occasions, companies will prefer the SaaS managed solution because it saves them time, right? Time to manage the software, to integrate, and dev enablement shifts from DevOps dependency to a cloud lock scenario that in the overall trade-off is worthwhile. And SaaS popularity is likely only to rise as organizations shift more and more resources to the cloud. So to sum things up in regards to adopting open source, there is no really right or wrong when it comes to the adoption. It's a matter of perspective, and there are multiple factors to consider. So you should choose what's best for your needs. And speaking of your needs, how do we choose an open source project, right? Because maybe I Googled my use case, I found 2, 3 projects. How do I know which one is the most suitable one for me? So we have some questions that we can ask ourselves and found the answers. And based on these questions, we can know and choose the open source project that is right for our needs. So these questions are revolving popularity, activity, security, readiness, documentation, ecosystem, ease of use, and roadmap. So let's cover each one. Popularity. Does the project has a high count of GitHub stars? If so, it could be a good indication that it is a popular project. Is the project part of CNCF or incubator? Because if so, it gives you like a signature that is this project follows high quality standards, which can lead to a popularity of this project. You should go Google the project alone to check for online presence, but you should also Google it versus similar products to check for reviews. Next up is activity. Check the commits rate. Are they daily, weekly, monthly? How many issues are there? How many releases are there? Is the project maintained by one developer or more? Does the project have sponsors, companies that believe in the future of this project and willing to invest money in order to see the project come more to life and be more active and more robust? So all of these questions are meant for you to understand that if you will incorporate this project and you will wait for a bug fix or a feature, how long should you need to wait in order to get those? So it's a very important thing to check. Security. So check for known vulnerabilities and supply chain considerations. I also put a link here for tools to checking security risk open source dependencies. So security is very much needed consideration. We see supply chain companies and products emerge more, I think, in the last year. So it is very, very important to check because it could be like the make it or break it kind of thing for your environment if you incorporate a tool that has issues. So make sure you involve security in your considerations as well. Readiness. Is the project declared as production ready, like Kedar that I mentioned? Are the current features enough to sustain usage? And is my use case covered fully in the current state? And if not, am I okay with it? Because if not, maybe I can keep tabs and wait for the next version to come out. And maybe this version will be in more ready state for me to use. And then it will be better for my use case and for my environment. Documentation. So documentation is basically the gateway for the project because you don't know anything about this project. So, and this documentation is like the gateway for you to understand what the project is all about, how to integrate known issues and explanations about the features. So if the documentation is rich and cover most aspects, then it will be really helpful for you both to integrate and to use it in a daily basis. Ecosystem. So I think it's very, very, or almost the most important metric here to consider, because this is the metric that will help you in your day-to-day maintenance. And I will explain. In one of my previous companies, I used Rundeck as the CI tool. And at that time, Rundeck wasn't quite mature. The documentation wasn't great. And the ecosystem was very small. So when I had to incorporate new functionality or enhance some flows, it was very hard for me back then because, again, the documentation wasn't great and I didn't have people to reach out to and ask for help. As opposed to that, in other company that I worked for, we used Jenkins as the CI tool. You can say a lot of things about Jenkins, but it has a very large ecosystem. So if the project that you're considering, the users are engaged on GitHub, and maybe also the project has a dedicated community channel like Slack, Telegram, Discord, or any other, it will really help in your day-to-day because integration, if the integration is hard or complex, but the ecosystem is very large, then you will know that in your day-to-day maintenance, it will be easier enough because you will have community to rely on to reach out for help. But not only that, community that is big means that a lot of users are using this tool, which means a lot of use cases are already covered. So it's a very important thing to know in your day-to-day for your day-to-day maintenance. And last but not least, is the project defined as an open source project or plan to go towards monetization? Because if it is planned to go towards monetization, it means that it will shift from open source to closed source. We all know what that means, so we need to consider that. And we also need to check features planning. So if the project has features planning, it means that the project is well thought of. They have, like same as work, right? We have roadmaps, we have things and vision for our project. So if this vision is communicated in the project's public eyes, it means that it has a future. It will perceive as one to be more active in the future, which is good to know, especially if we're going to integrate it in our production environment. So I covered a lot of questions here and metrics of how to choose an open source project. So in order to sum this up, ask the general questions to cover the basics and check if the project is in a ready enough state to incorporate generally, but also ask the tailored specific questions to cover your use case and your pain points. So for example, if you have a heavy use case, then you should focus and really rely on the documentation and ecosystem metrics. And if you don't have capacity for maintenance, for example, then you should focus and put more weights on the readiness and ease of use metrics. Do a POC, see how well it gets integrated in your environment, and rely on your research ecosystem to the rescue. Engage in GitHub, raise issues, and contribute for the project success and eventually your success. And yeah, I think that's that. And another thing, like a small token for me, if you want to contribute to the open source realm without writing a single line of code because you don't have the time to do it, or you're not really a dev person per se, then there are other ways you can contribute to open source. So you can open issues, bug fixes, or feature requests. That way you contribute to the project robustness and for its future. Modify documentation. So documentation is skill. So if you have the skill, please utilize it in order to make the documentation much more readable and clear and concise. As I showed you, it's also a metric to choose an open source project. So maybe because of you, someone will choose this open source project. So if you have the skill, please leverage it. Everyone will thank you for that. Share your use case and write blog posts about open source projects that you know about or used. For example, I helped incorporate an open source tool called a script server in my previous job with my team member. It's an open source tool for exposing Ansible playbooks and Terraform code through UI with permissions set up as well. So it's an awesome tool in my opinion. So I shared it in a blog post and hopefully people will read it and maybe see that it's good for their use case, and that's what, and then we'll adopt it as well. Share tools that you found with colleagues and techie friends. It's also good for them to know. A company or individual sponsorship. So as you know, projects that are not backed up by companies sometimes really need the money in order to keep maintaining this project. So if you're able to contribute some money or help convince your company to invest in sponsorship of open source projects, then it will be a blessing. Hold an open source mindset. So aim to incorporate open source projects wherever possible and reasonable, because if I do it and I share it with other team members or other people in my company, maybe this will make them think about open source as well, and they will get inspired by that mindset and maybe adopt it as well. And last but not least, spread the word on open source at conferences like I'm doing just now. So that's it. I hope that you enjoyed it. I think that we have time for Q&A. If so, just I'm here for you. Thank you so much.
Hello again, Hila. Thanks for the awesome talk.
Thank you. It was
Hope you had fun. You certainly looked like you did.
Yeah, I really like open source. I like speaking about it. I really think it's a very important realm to both contribute to and be part of. So yeah, I really enjoy it.
Yeah, I could see the fire in your eyes. That's why I asked. Okay. So you're ready for some questions?
Yeah.
So first one would be, would you recommend OSS adoption for startups in order to reduce budgets?
Yes, there is no anything that prevents startups from adopting open source. As I showed you, since your startup, maybe you don't have time or capacity for maintenance, then you can just put the weights on the metrics that I showed that will help you adopt an open source project that is quite mature and wouldn't require you to have too much maintenance in your day-to-day, and that way you will benefit from all worlds, both covering your use case and not need to have too much maintenance in your day-to-day. So definitely.
It depends, like so many things.
Yeah, but I work the script server, the tool that I incorporated, it was in a startup and people used it, all was good. It actually enabled the developers to do their own thing without having to rely on us too much. So it is totally possible. Of course, the grain of salt is that you need to check things and really know what you're going towards to. That's why I have all these metrics to make sure that you know exactly what you're introducing to your environment. But overall, yeah, it can be done, and it can be done in a good way.
All right, thanks for that. We got another question for you. Do you have any ideas of how to make open source license handling easier? I would like template projects that you can start from that is reviewed by lawyers in advance. Many GitHub projects doesn't follow the obligations according to the dependencies they use.
Okay, so I personally have less experience with the open source licensing, but I can, if this person will reach out, I can connect him to other people that are more involved in open source licensing stuff, so they can reach out to them. And also, I'm sure that if this person will post about it in certain projects or in communities, people will be more than happy to help. So I currently have less experience in this area, but I can help offline with connecting to other people who can help.
Yeah, you already shared your contact information, so just hit Hila up. She is, as you have heard, she's happy to help if you got some more questions. So another one, you are a senior DevOps engineer. Maybe you want to elaborate a bit on how do you become a DevOps engineer in the first place?
Sure. So my background is being a system admin. Then I switched to DevOps, which basically means that we are no longer, collide with developers. We want to enable them to do their jobs. So DevOps is much more than tools. It's a mindset. So once you have this mindset, yeah, you can learn some tools, but the most important thing is the culture. So if you are willing to change your ways, the old ways of system admins where we say no and we want to say only yeses, then the transition will be much easier. In terms of tools, then yeah, cloud providers that are out there, AWS, GCP are the most known ones. Azure tools, Terraform for infrastructure as code, Ansible or Chef or Puppet for configuration as code, Jenkins, Circle CI for CI, monitoring, Prometheus, Grafana. So I think the most the greatest tip I can give you in this transitioning is to create a project of your own, because you don't have the experience in a work environment. So create a project of your own of a robust system with all the moving parts of monitoring, CI/CD, performance, and all of these kind of things. And then you can speak about this project in interviews. And even though you don't have the work experience, you will you will show the employers that A, you have the passion, that's why you worked on it on your free time, and B, you can defend the decisions that you made during this project, and then they will see that you have the necessary knowledge and intentions when it comes to building systems.
All right, and maybe apart from all the information you gave us, do you have any go-to resources that you maybe also used in your process of becoming DevOps engineer? Like books, blogs, I don't know, YouTube channels maybe?
So I don't remember specific ones, but in general speaking, I can say that the book of Google of SRE is good because it really explains the principles of being an SRE. Some companies have separate positions for SRE and DevOps, because DevOps is more about the automation and DevOps and dev enablement, as opposed to SRE, which is much more about site reliability and making the system more reliable and resilient. Some companies have this two jobs merged, some don't. So it's good to know this aspect as well, because as I explained in my talk, the system and the environment stability is the most important thing for us. So this book is good. O'Reilly's books are very, very good for anything. So there are books for Prometheus and Terraform and Ansible, so a lot of things. These books are very good to learn a specific tool, but they have books for design and architecture in general as well. And there are people that you can watch online. So I don't recall something out of the top of my head, but there is a Twitter thread that I can share with a lot of recommendations of people to watch out for, and like I don't want to say influencers, but people that are have a tendency to communicate their work more frequently, and you can follow them and be up to date of what's going on in this industry.
Right, thanks for that. Maybe a bit off-topic question, but nevertheless maybe interesting for some folks. What kind of music do you play in your band, and more importantly, where can I listen to it?
So my go-to music is pop rock. So we covered songs like Muse, Alanis Morissette, Radiohead. So this is my favorite music. Of course, there are other band members that have different kind of music that they like. So we also switch it up a bit. And there is a playlist of my concert. I can share it with you, and you can share it with the people or in the chat, whatever you think is best. And if you watch it, it will be awesome.
Yeah, I will certainly listen to it. Just share this playlist, and we will share it in the chat.
Awesome.
All right, Hila, thank you so much for the talk. Thank you so much for joining and sharing all this awesome information with us. Hope you have a nice rest of the day, and goodbye. Till next time.
You. Bye, people. Enjoy the rest of the conference.
Bye. All right, and now to the audience. Now after this third talk, you have a little bit of time before the fourth talk. Maybe you could use this to go to WeAreDevelopers.dev to pre-register for the upcoming WeAreDevelopers World Congress 2023. And with this pre-registration, you save yourself the benefit of a discount code. All right, and now before we go to the fourth speaker, we'll have a break of about 20 minutes. Stay tuned. Welcome back, everyone. Now, before we start with our next speaker of the day, quick reminder to scroll down on the live page and sign up for our giveaway, because together with Deloitte, we want to give you a MetaQuest 2 VR gaming headset. So don't miss out on this last chance, because at the end of this topic day, I will announce the winner. So, and after that, right to the next speaker. She's Microsoft MVP, has lots of experience in developer relations, and organizes meetups and events. Welcome, Suzanne.
Hey, thank you for having me.
Hi, Suzanne. Wonderful to have you. Hope you're doing fine.
I'm doing well, and I get to talk to you about one of my passion topics. So that's already a good thing, right?
And what the topic is exactly? What is the topic exactly?
Yeah, so I will talk about improving your developer experience and how you can use an open source project to help that.
Right, Susan, sounds interesting. The stage is all yours.
Great. Well, I'm happy that I passed that check. So thank you for joining. Yes, there was already a little introduction. I'm Suzanne Daniels. I work for Spotify as developer relations lead for an open source project called Backstage. It's a tool for improving your developer experience. Now you might be like, wait, what? Spotify is this app on my phone or on my computer or on my television or car. Well, yes, but to make such an app, there's a lot of engineering efforts, and we have open sourced one of our most important tools to realize all that programming and put all that services up there for you to enjoy. So I will tell you all about that more. But first, let's look at modern day development. I tried to find a picture which summarizes modern day development. I have to switch to my thing. Yes, that's good. So a picture to summarize modern day development. It's a bit of a facepalm picture. Why? Well, modern day development is pretty hard. It's confusing. New people get onboarded all the time, but the information you need to transfer is getting more and more complex. Creating an application, and here it doesn't really matter if it's the most modern microservice architecture or modern monolith architecture, or maybe legacy applications, because for each of these things, you need to collaborate with other teams to provide a service, that application to your customers. That is super confusing because documentation is spread everywhere. Migration projects often fail, and it's hard to keep up with the knowledge in your own domain, let alone new domains. Maybe you're a front-end engineer. How much experience can one have in maybe data science? So today, because Spotify is no different, I'm going to share some secret sauce with you. So after this presentation, it will be not so secret sauce anymore. Let's step a few years back. Now, Spotify is known not only for the music app, but also for the engineering culture. A lot of blog posts has been written about the Spotify model. I still regularly encounter conference talks about the Spotify model. This is a graphical representation, which I find funny because it shows how complex collaborating actually is. But to make that all work in Spotify, yeah, you also need tooling. You also need a platform to collaborate on. So a little over 10 years back, Spotify was a smaller company. We had less engineers, but we already had quite a complicated infrastructure. Onboarding new engineers was becoming increasingly difficult. To share the knowledge with them, to get them up to speed, it required really a lot of effort, a lot of attention to get them up to speed. Then finding the right information is also complex. Why? Because we have these autonomous teams, right? And one way or another, they need to engineer stuff. So they need tools for that. They maybe need a documentation platform for that. The documentation platform, which the rest of the organization uses, well, maybe that's not suitable for what they need to do. Maybe the tooling that platform team gave to them, maybe that just wasn't enough. So fragmentation started happening. Then trying to find out who's running on call for what service, also a difficult problem to solve. So what did we do? We put together a team to create a portal. And that was our internal developer portal. And basically it had that information. So it had somewhat of a catalog functionality, comparable with maybe a CMDB. It showed who was running on call. People could find some documentation. And it was pretty good. People loved it. But then I talked about these other new areas where people were working in, like ML, for instance. You have specific requirements. And to get them into that portal, you need to extend functionality. If you to bring self-service functionality, that needs to be added as well. And the application we built wasn't actually that suitable for extending. It wasn't that suitable to create new types of information, new types of services. And that was a bit of a problem for the team maintaining it. So at some point, onboarding in Spotify was becoming hyper confusing. And the internal fragmentation, well, it was there still. Because if you can't get that information into that portal, you start working around it. At some point, adding new engineers to our organization actually slowed us down. So that was a bit of a problem. We needed to change something. So we went back to the drawing board and reimagined what is a developer portal. So we chose another programming language. We created a framework which was extendable by plugins, so that we can have the feature development decoupled and isolated, and actually putting the power into the hands of the teams to create the plugins with their domain knowledge, with their needs. We built this product to tame the chaos, or, well, like I like to say it, embrace it. We extended it to host more data pipelines, websites, other types of information, other types of services. So with that new tool, we were able to bring together our thousands of engineers spread across 100 squads and bring in our 20,000 software components. And our idea was to tame that chaos to enable better collaboration and unlock our collective potential and empower the teams to do what they do best and not hold them back. So this is the 3 things that we came to after some research. So we wanted speed, but we wanted to keep the safety. I don't want to keep the guardrails. We want to scale, but we did not want to lose the quality. And we needed to embrace that chaos. And at the center of that was this tool, this developer platform, which people could extend and could build in everything they needed to be successful in their work. And that new platform, which we named Backstage, was a huge success. So we have a small team maintaining Backstage. It's about 6 people. 80% of all the contributions come from outside our core team. And those plugins are really a hit. over 120 plugins are being used every day. So when we started doing this, we measured the number of days it would take for an engineer to get to the 10th pull request. And with Backstage, it was down to 20. Okay, but when you were in a problem, when was that? How was that? Well, how many? Well, 60. Just imagine. But that doesn't tell much about the happiness. So for that, we have an internal engineering survey, and people can rate basically everything they use. And Backstage scores a high score there. And our aim is always to get that up. So we talk a lot about our engineering culture, and people ask us, hey, but what's that tool you use? What is your tool set? How are you successful? And Backstage popped up more and more. And people were really interested in, hey, can we maybe use something like that at our own company? Can we build that ourselves? And we had a lot of discussions around that. And a little over 2 years ago, during our Hack Week, we went ahead and we open sourced it. And we open sourced a new and improved version of Backstage. Why? To put the power into the hands of other companies, while also ensuring that Backstage would be the best developer experience in the world. And we want to offer that to our developers. And we want you to offer that to your developers. It was a success. Over 1,000 contributors contribute to this project. And a large part of those also commit code on a regular basis. And we know that over 300 companies adopted Backstage, trusting, building on Backstage, their developer happiness, their developer experience. Now, there was this talk just before my session. I don't know if you've watched it, but these are important metrics. So we have 18,000 GitHub stars, more than 100 PRs per week, and we have about 7,000 members on Discord. And shortly after open sourcing, we donated the project to the CNCF. And the Cloud Native Computing Foundation actually owns this project. And that is very, very important for the future of the project. Just this year, we went to incubator status, which is a huge achievement. And we've released version 1.0 earlier this year. And we're moving full steam ahead in releasing new versions on a regular cadence. But I talked about the plugins. So we have a huge ecosystem. And those people also create plugins and extend functionality. So there's over 60 plugins available for you to leverage when you want to improve your developer experience using Backstage. Just go ahead and take a look at those plugins. Maybe there's already a tool that you're using, and you can leverage that plugin. Think also of vendors like PagerDuty and Sneak and FireHydrant. They are integrating with their own first-party plugins. If you create a plugin, you can also share it with the community, giving across all those adopters, all those community members, a chance to improve that plugin and make it the best experience possible. But there's more to adopting an open source project. You get to engage and collaborate with a large community, a welcoming community. You have this continuous community support, and you're able to not only contribute by creating plugins, but also by contributing to the code of Backstage or anything around it, like blogs and videos and documentation. So enough talking of Backstage. I think it's time to show a little bit. So let me switch to the demo. And for this, there's a little backstory. So let's imagine I am this engineer. You see here my badge on the screen. I just started working at Rocket, which is an interstellar travel agency. It's pretty much like a Uber for space. And I onboarded there, did the whole HR thing, which was not maybe that useful for me to get an idea of what I should be doing every day. So I opened up my shiny new laptop, and the first thing I did was I go to their internal developer portal, which is Backstage. Great, so here I am. Now, during the onboarding, they pointed to this onboarding document, which everybody in engineering goes through. So I go to the documentation part of Backstage, search for my document, see it right here, and I'm going through this onboarding document. This is called the Golden Path. It's something that we also use at Spotify, and this helps me basically set up from beginning to end my microservice. And it starts at the very, very beginning. So helping me understand a little bit about my place in this constellation called engineering. How this engineering platform actually works together, how it stitches together. It helps me set up my deadlocks. So I have some local dependencies I need to install before I can get started with my coding, my IDE, and from there I will go on and create everything around my project. So at the end of this, I have experienced a few things. I have experienced how I actually set up my environment. I have experienced how I not only set up my application or my data pipeline or anything, but everything that relates to that. And by going through this golden path, I also very playfully learn how Backstage works, because everything that we do in this organization is done through Backstage. So deploying a new application, deploying a new environment or a platform, that is all done through Backstage. Finding my documentation, that's what we do in Backstage. So I have a really, really good idea at the end of this golden path, how I should use Backstage and how I can actually create my application and how it relates to the rest of the engineering organization. Those APIs I talk to for my other apps. Now, in that first week, I will have already created my first application. Not the next $1 million app, but at least it displayed some information and it looked really good and it worked. So that builds up confidence. Now, one of the other things I can do in Backstage after I'm onboarded is finding out what other applications are being hosted in this at this company. What other things do we build? So this is the catalog functionality. So here I can select on my team name, and I can see what applications my team own. So I'm going to click the lunch application. This is, by the way, an application for ordering lunch in your Rocket. Very useful. And if I click on that, I come to what I would call the homepage of your service, right? So this displays all the most important information, like where can I find the source code? Where can I find the repo? Where can I find the owner? What does it belong to? I can create an incident or maybe see who's on call, maybe some important statistics, security alerts, and that sort of stuff. So I don't need to switch to some portal to get the information and the latest status of my service. I just have it there right in front of me. I don't need to go to the portal of my incident service. I can just stay here and just already have a great look. The whole idea is here to have less context switching, to not switch to another portal again and again. And if you're wondering about those plugins, well, basically all those cards are plugins, and there are many available. You might recognize some logo here or there. And you can enrich the content here, depending on your needs. So let's look at, for instance, CI/CD. So this is a good example of a plugin leveraging the API of my provider. And in this case, it's GitHub I'm using. So I can immediately have a glimpse on how I'm doing, what the status is. I can see where my pipeline may be filled. And I still need to go to either like my IDE or my cloud portal or to GitHub to fix my action. But this already is really helpful for me, because if I need to fix anything, I can just stay here and be really happy with my green bulb here. And behind these steps are all different plugins which you can use. For instance, looking at the incidents, this is the Rootly plugin. So I can see the past incidents, but also the current incidents. I can, for instance, go to look at my Azure resources which it uses. So it uses the tags to display the resource group. And if I click here on the tags, I go directly to the portal to search for everything with that tag, or directly to that resource group. And I have some security recommendations. Maybe you would want to put them on your homepage, but that's all up to you. It's up to you to create the best developer experience you can imagine. So, okay, let's take a look at another application, which is the Bookings app. So let me take a look. And hey, there is no Bookings app. Well, that's a very, very good reason to maybe add the Bookings app to this. So let me go to the repo. So I know for a fact that this Bookings app, it is hosted on the repo is hosted on Azure DevOps. So I'm going to use Azure DevOps here, and I've already created the necessary metadata file. So this is basically how you configure that one service. So it contains some metadata, like a name, the description, on what it depends, what it consumes, the owner, but also you can configure the plugins. So as you see here in the annotations, each plugin has a line, and I can extend it by putting in the right configuration there. So, okay, I want to add this because, yeah, I forgot that before the demo, sorry for that. So let me just go to create, register the component. I'm going to add the URL. I'm going to learn pasting. It will analyze if it's valid. I can see what will happen. I can import this, and that's done. So if I open this this surface, this is the Bookings app. So ordering lunch is obviously a part of your booking process. So you can also see here that it relates to the lunch app because it depends on that app. So if I want to check here the pipeline, and you notice that it was Azure DevOps, so I click CI/CD, I know what I can expect. I can expect the pipelines there. So what is important to notice here is that I chose to put it under the same CI/CD tab. Why? Because context switching is hard. And because Backstage is basically a large bunch of TypeScript as well, you can easily put in an if statement and determine what information gets displayed in what part of the app, so that I have a consistent experience. Because I don't care if my pipeline's all right. I don't care where it runs, right? I just want to see if it runs, if it was successful, if I made that one mistake again. Yeah, and I can also take a look at the documentation, which is with this project, or in this case, yeah, we didn't do that yet, so maybe we should add that, but let's do that at a later time. So looking at that API, because you've probably seen already that I depend on an API for everything I do. It's the Flight Info API. So again, there's also this page. This would contain all kinds of useful information. The imagination is here for you to imagine what things you think are important to show, right? But one of the most important things for me, because I want to use this API, is the Swagger style docs, so I can actually go ahead and leverage this wonderful API to start building my own microservice. So let me not dwell too much. Let me go to software templates. Software templates is a way to consistently create things, to deploy things, to spin up things. It is there to make sure that things are happening according to the best practices. Maybe you have some regulatory requirements. You can ensure all these by using software templates. So for instance, in this example, I will create a React app. It will create the template in a new repository and, well, give me a head start for me to start writing my application. But it could also create a ticket for my networking changes or firewall changes, or for registering my new services I'm gonna spin up to host my application on. That could all be a part of this. So let me go ahead and go through this, this wizard. This asks some questions. As you can see, I need to select an owner. And you can see that those are team names. Now, one of the concepts of Backstage is that everything is owned by a team. So I choose my own team. I can select a host. So I've set up these three integrations at this moment. So I'm going to use GitHub. I will select the owner, which is my, my organization in this case. And I will create a new repository. And I can check if the information is right, then it will create it. It will copy the skeleton files, but this could also create maybe already my Grafana dashboard. Again, everything that you need to do, you could put it in there. Now, one of the big advantages is that I do not need to switch to another tool, go to my cloud provider's portal, go use some a tool for which I need to know the specific commands I need to type in on the CLI. Everything is in this one place. So if we're lucky, and we are, it created a repository with the skeleton files. And it also created the component in the catalog. So I didn't have to type all that YAML. And if you want to import like information from other locations, then you can do that writing a custom entity processor for that, so that you have that information in there. But to make sure, Backstage is not there to replace your tools or to be the single source of truth. Backstage is there to aggregate all your single sources of truth and put them in one place, so that you can actually leverage the information, so that you can actually use the tooling in a more friendly way. In the presentation before, there was an example about adopting open source tooling. That is hard. That's also creating a lot of friction. But what if you can have a team implement that open source tooling, but you can create a plugin so that everybody in your organization can benefit from it in a way that's useful for them, so that they can consume the information in a frictionless way. Yeah, another example of a plugin is, for instance, TechRadar. So if I would create a new project, I would like to make sure that I am using the right set of technologies. So this is how I would view that. This is a plugin leveraging a static file and displaying it on your screen. I will go more into the plugins a bit later. And yes, searching information is really good, but finding information is maybe even more important. So we have a really extensive search functionality. So for instance, if I would look for that lunch app, it will not only show me the microservice, but it also will show me all the relevant things for my app, like my documentation. And you can hook this up to to other sources. So for instance, if I have a bunch of documentation on Confluence, I could hook up the search to the Confluence so that it gets displayed here, and I can easily access that documentation. Because switching things and not being able to find things is a frustration. I'm pretty sure if we could see each other, you'll be nothing like, oh yeah, don't get me started. Search tries to help you solve that. And that brings me to the end of this short demo. So I will continue with the presentation. So why? What would be reasons to start using Backstage, to adopt it in your company? Well, like I explained before, the developer landscape and being a developer is becoming increasingly complex. This alone is the CNCF landscape card map. It shows a bit of a selection of the services you need for modern day software development. But I'm pretty sure if we would list all the tools the cloud providers provide and all those vendors provide for you to be excelling in your software development and the hosting of your software, it would be not fitting on any screen anymore. And you need to be able to adopt that tooling and to embrace that chaos. If you would look at all the things you use in your company and you would put them into ads, it would look a bit like this: chaotic. Oh yeah, for observability, yeah, we have this and this and this and this tool. Okay, cool. Yeah, we have one portal. Okay, great. Then there's the documentation team, and they're like, yeah, we have this portal, and we have various portals for shipping our software, and we use some plugins here and there. But still, for each of these things, I need to learn. Each of these things, I need to switch to another system, to learn a new language, to learn a new framework, to learn a new cloud portal. And that takes a lot of time and a lot of effort. So let's look at what things are important to be a happy developer, to be a productive developer. So for this, I'm gonna skip a little bit through the space framework. And the space framework is developed by people from the University of Victoria, Microsoft, GitHub, some really smart folks who really know their stuff. And I'm going to relate this a little bit to what might be your situation. So if we talk about satisfaction and well-being, then you could also talk about your community, your teams, the tooling you have. How happy are you? How satisfied are you with that? Because if you look at speed or productivity alone, it does not say anything about your happiness. If you look at performance, that is more about the outcomes of what you do. So that is about maybe your customer satisfaction. It's about gaining insights. Having that available for you, having that insight, having that on your level, being aware of what you're actually contributing to is really, really valuable. And it helps with better understanding things. Now, a lot of the times when we talk about productivity, a lot of the people think about the activities, which is mainly your actions, your outputs, things you can count. And those might be really, really up in your team, in your company, but that doesn't say a lot because they might go up, but the person might be running into a burnout or the code quality might really, really suffer. It doesn't tell the whole story, right? But if you look at it on different levels, it does make sense. But mostly to you, to be able to see what you are doing, how you are doing. Having that visualized in one place is really, really useful. Collaboration is about how you work, how you communicate. Do you want to do inner sourcing? Do you want to build on top of each other's success, contributing? Transparency is very important if you want to drive change or adopt a new technology. move to a new platform. But also awareness, like being aware of what other people are doing, having those insights, being able to learn by yourself without depending on resources of other teams, which actually also are in the same boat as you are. Think of onboarding, so retention, documentation, and exchanging expertise. It's what a developer portal can help you with. And there's the efficiency and flow. And I mentioned a few times, it's a distraction. It's a hassle. You need to go through so many systems. Anything you do which is different, or you need time to look at further, is something that, well, distracts you. It gets you out of that flow. So to summarize, Backstage is one front end for your infrastructure. It is not the silver bullet to create and replace all your tooling. It is to embrace all your tooling. It is not an internet for developers. It integrates your CI/CD, your monitoring, your security, your testing, all your services that you have and whatnot. Your documentation, wherever that might be, and what kind of documentation it might be. And driving autonomy is really important because it's basically the success, because you have this collaboration internally. You give people the freedom to move, and that way you can collaborate. Each component has one owner, and that's the owner with the ultimate responsibility, and usually that's a team. So Backstage, usually you manage it with a small team. And you have the platform teams, and they build and maintain the plugins. And you have teams who own the software, who build the software, and they leverage all that functionality. They're basically your customers. And you need feedback loops for that. You need a community feel for that. So there's a few levels of plugins. So one I've shown you already, it's the Tech Radar plugin. It's basically a file, which is quite static, and that information is displayed. You have the GitHub plugin. It gets the information from the GitHub API. It leverages a Backstage proxy. And you have the Lighthouse plugin. But I show you the documentation plugin, so I'm going to go with that. The documentation plugin, you have the front end, you have the back end, because there's a lot of business logic in there. The documentation, tech docs even uses Kubernetes under the hood, and it uses a database. So that's more extensive than that. And you can create a plugin anywhere between 2 hours, 2 days, or maybe 2 months if it's a really extensive. But you can do that. And you can teach other people in your organization to do that. So we've seen how we can create new software according to your standards. We have seen how you can manage the software and how you can find your information. The plugins, well, it's basically an NPM package you use, and there's a command which will help you with a template, and it can kickstart really your plugin development. And we will, in the next month, release a plugin creation course on our website. And even if you're like, well, I don't know about Backstage, well, at least invest in developer experience. Because happy developers make happy code. And if you don't invest in it enough, then your developer will still be really, really happy. Here's one with some bugs in his hands, walking away from your office. That's not what we want. So yes, you're already busy. You have 20 bazillion software components running in production, docs spread all across the company, all the tools you can imagine, and you're onboarding new engineers at a rapid pace. So yeah, where do you start? Well, start with one problem you'd like to solve, a narrow use case, and build up your experience. Your experience with Backstage, with maybe TypeScript, with the community, with working with open source, with getting a better understanding and feeling of that, and from there spread the knowledge and spread the enthusiasm about it. And build out your developer experience. Don't try to solve everything in one time, but grow your internal community around it. And I would like to thank you for watching this presentation. Here's a QR code and a link. You can use that to get to a very, very special page, which is there for you to help you to the getting started documentation and all kinds of other useful information. And you can also there subscribe to the newsletter because, we have a lot of news coming up. So thank you for that. And if you decide using Backstage, or if you're already using Backstage, reach out and let me know how you're doing. Thank you.
Hello again, Suzanne. Thanks for the awesome presentation. Happy developers make happy code. Love that phrase.
Yeah, and I hope that that will be in the minds of people, because it is so important, especially now that every company is a software company. We know that the developer workforce will grow to over 40 million, I think, in the next few years. We really have a lot going on here. Technology is not getting more easy, and where it gets easy, we're solving more complex problems. So yeah, it's important to keep that in mind.
I agree 100%. So, Suzanne, are you ready for a couple of questions?
Yes, I will try to answer them.
Happy to hear that. So one would be, what are the main advantages of your platform in the market from many other that are similar?
So the biggest advantage of Backstage is that it is extensible. It is extensible by using the plugins. It is extensible because it's open source. So our vision on this, and we could have maybe sold this platform, but we didn't. We made it open source because we think that it is the best way to create the best developer experience in the world. And that is something that how big ever your team is working on a product, you just can have all that knowledge and all those different perspectives. For example, we can think of a tool and think well, this would be very useful for an engineering organization. But then an adopter might think, well, we also have this other part of the organization, and they would really, really benefit of this. You can build that. You can do that. And it's all supported because Backstage is not opinionated in any way.
All right, hope that explains that. As we got another question, how many data engineers and data scientists do you have in your team?
I'm able to answer that question, but we have a few.
A few. Okay, maybe when talking about your team, maybe you can give some insights on what you're doing the whole day, what your workflow is, maybe.
Yeah, so I work in Spotify in the Backstage team. We work on a number of things. I'm mostly focused on open source, so on the project, on the community, on adoption. So we work a lot with our product people and engineers who work also on this project and making it a better experience. We also have a part of the team which focuses on driving a commercial solution to make our investments sustainable, which is, like you learned in the last presentation, is also important for open source projects and ensuring the future of it. So yeah, we have a quite wide team with a very wide number of people with expertise, like user researchers. We hopefully will embed a data engineer, data scientist. So we have a lot of knowledge, which it requires a lot of different types of knowledge. The work we do at this moment.
Okay, sounds
And I'm part
fascinating.
of DevRel, so I focus on documentation and community and yeah, in general, the adoption experience.
All right, thanks for clarifying. Maybe if you've seen the other talks or other topic days, maybe you know that I always love to ask if you have any other resources to share, like books, blogs, maybe YouTube channels, something like that fit your topic.
Yeah, so basically all the links are in the links page, which is, somebody can share my screen still, then you can go there. So we have a YouTube channel where we have recordings of all the community sessions. So we have them regularly twice a month. So one for adopters, which is more about sharing experiences with adopting Backstage, but also helping each other, gaining better insights and learning from each other on topics like inner sourcing, developer experience, onboarding, retaining talent. Like there's many topics related to Backstage. Backstage is just a platform. There's much more to it than the technology itself, and we like to discuss that. Also, there's the contributors meetup where we talk about contributing to Backstage, about functionalities. We have discussions. So those are great resources, and yeah, there's a link to the blog as well. And yeah, there's various communities around this, like Inner Source Commons is a great one. You could definitely join that. Platform engineering is a fairly new community. So yeah, there's many communities on these topics, and yeah, it's really great to be there and to learn from that. So I highly recommend that.
Communities are always the best source for information, also from my own opinion.
It goes faster than writing a book mostly,
Yeah,
but I don't want to diminish books because I love reading them.
Me neither. Right, Suzanne, thank you so much for the awesome talk and the Q&A. Hope you have a nice rest of the day, and till next time. Bye.
Bye, folks.
All right, and before we start with the final speaker of the day, we jump in a break of approximately 13 minutes. Grab a coffee or a snack so you stay fit for the last talk of the day. Stay tuned.
found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back, everyone, to the final part of this live day. So before we start with the final speaker of the day, remember, scroll down and sign up for a giveaway, because together with Deloitte, we want to offer you a MetaQuest 2 VR gaming headset. Don't miss out on this chance and sign up. And after you've done this, listen to the final speaker of the day. She is developer advocate at Aqua Security, has a passion for making tools and platforms more accessible, and besides all of this, she also finds time to run her own YouTube channel. Welcome, Anais.
Hello. Hi.
I hope I pronounced the name correctly.
Yeah, it's Anais. No,
Anais.
it's good.
Okay, I'll remember her now. So Anais,
You're German. You
so
could
much-
try my last name as well.
Oh,
No, don't. All good.
maybe
Okay.
next time. All right, Anais, how are you doing today?
I'm good. How are you?
Oh, I'm fine also, thanks. So maybe you want to tell the audience and me 1 or 2 sentences about the topic of your talk today?
Yeah. So basically, my talk is about getting started with security in the cloud native space, but it really also applies if you're a DevOps engineer or if you, if your job is related. And my examples are going to focus on the cloud native space, but I'm going to basically talk about getting started with security and choosing tools and getting started with those tools, the differences, what are some of the mistakes lots of people do and how to prevent them.
It's a very important topic. So I would say without further ado, stage is yours.
Amazing. Okay. Yeah. So this talk is called Climbing High, the State of DevSecOps. I'm going to talk about the title in a bit more. A bit more about myself, just to give an overview, so you know who I am beyond having a YouTube channel. I'm the open source developer advocate at Aqua Security. So whenever I'm mentioning anything related to Aqua, know that I'm only talking about the open source tools. I'm not using the enterprise tools. I'm really focused on the open source projects that we have. Last year, I was working as site reliability engineer. So a lot of the ways that I'm talking about security is from the observability monitoring perspective and keeping in mind observability tools in the cloud native space. Before that, I was working for several years as developer advocate as well. However, only since the end of 2020, I'm in the cloud native space. So here's kind of a screenshot of my YouTube channel. I post on a regular basis full end-to-end tutorials, and most of the tutorials also have a written version on my blog. So if you're curious about that, check it out. I also have a weekly DevOps newsletter where I share free online content from the space. That might be something interesting as well. I also have a 4-month-old puppy. I just want to mention that because she's right next to me and she might make some chewing or scratching noise or bark in the background. So I apologize for that. But her being so adorable makes up for that. Going back to the title and the presentation, Climbing High. Why did I choose that title? I like to compare real-world metaphors with concepts within the tech space to make them more relatable and explain them in different ways. If you've listened to a similar presentation of mine earlier this year with the same title, know that every presentation I give is slightly different. So this presentation has a lot of content that I haven't given before, just to mention it. So stay tuned, stay on this live stream, even if you've listened to a presentation of mine before. So earlier this year, I got started with bouldering. You can see here these 2 photos of mine trying to get up on this bouldering wall, right? Now you have to think about that way, that this is really like a constrained environment. It's only like a few meters high that you climb. If you fall, there's not much that can happen. You fall on a soft ground, everything is fine. And this is really like a practice environment. And similarly, when you get started with any other hobby, with anything else, you would get started in a small environment first. In kind of a demo environment where very little can go wrong. And it's really like cloud native security when you get started with cloud native tools, with DevOps tools, that you would want to get started in a small scale environment first before you advance to more complex production use cases. Here's another picture which shows a bit more difficult routes that people are taking to get up on the wall. Now, when you get started with Kubernetes, with cloud native tools, you would get started usually with a demo cluster, such as a Kind cluster. Kind is similar to Minikube, MicroK, Docker Desktop, any of those local clusters that you can easily spin up with a few commands, and then deploy workloads. And in this case, very little can go wrong usually. It's usually just a cluster that you run locally to play around with, to install some demo use cases, try out how to write YAML manifests, try out cloud native applications, and similar. Now, at some point, however, you want to advance to a more complex setup, to the next stages. Like at some point, playing around with a Minikube or kind cluster will get boring, and you might find it has a lot of constraints as well when you'd want to try out more complex use cases. And that's when you want to advance to more to the next stages, right? So this is a screenshot that's taken from my last year's KubeCon talk that I gave with my manager at the time. And it basically, high-level outline, this is the drawing of one of the compute racks that we had within the company. So we basically, we were working for a cloud-native service provider where you could run Kubernetes clusters, spin up Kubernetes clusters. And these compute racks, they would be in different regions. So you could spin up clusters in Frankfurt, in New York, in London, and so on. And what would happen basically, that clusters would be scheduled on these workloads, on these compute nodes. And these compute nodes would basically run the cluster, but the entire super cluster would also be kind of a Kubernetes cluster. So it was like large-scale Kubernetes cluster, and within you had those smaller tenant clusters running. And in this talk, we talked about the Kubernetes operators, the Kubernetes resources and applications that we were using to gain insights into all of the processes that were going on within those clusters, within those super clusters, to understand what kind of workloads are being run, how many tenant clusters are scheduled, to distribute workloads, and so on and so forth, right? So we talked a lot about the observability and telemetry of our supercluster design. However, we didn't really talk about the security or how we keep all those large-scale clusters secure. And one of the main issues that a lot of cloud-native, or also other corporations, companies face, but especially in the cloud native space, is that we're getting started with security too late. When we already have these large scale designs, that's when we're thinking about, okay, maybe we want to implement security scanning or similar into our production stack. And at that point, when you already have such a large scale environment, it becomes quite difficult to gain insights into the security of every part of your services. However, in comparison, if you're running a local kind cluster, it's quite straightforward to ensure that you're following best practices for those. And you're following, for example, compliance standards and similar. And the longer you wait, the more difficult it gets, basically. Now, there are lots of different headlines and lots of different statistics that show you the most common cloud-native attacks, most common security issues, how to prevent the most common issues of X, and so on. I'm not going to talk about that or go into detail in this talk. There's one statistic that lots of Kubernetes instances are found exposed. And that can also be, for example, when you have a local kind cluster and you have an external IP that you're not aware of, and that's accessible to everyone, right? So that can happen as well. And that could be local clusters, demo clusters can be part of these exposed Kubernetes instances. And in that case, that's obviously bad, but if it's just a local demo cluster, there's not that much that can go wrong. Again, once you have a large-scale production environment, there's a lot worse things that can happen when your services are exposed in a way that you didn't anticipate. Now, I want to talk a little bit more about the human component and I'm also going to talk about within this presentation about what we can do in different teams and with different backgrounds and depending on the tools and applications we're working with. But ultimately, it boils down to empowering people to take care and take ownership of cloud native security and just the security part of your workloads. And that's whether implementing security scanning locally to scan your local resources, or if you're working with CI/CD pipelines, implementing those, or in your running workloads and similar. Now, this is obviously a clickbait headline in a way of Red Hat Kubernetes Security Report finds people out of problem. Ultimately, it really that boils down on how do you ensure that people want to take ownership of security, of the security of your services, and are able to do so. Especially in the cloud native space, you have a lot of people who get started within cloud native with Kubernetes and similar tools, and then they move towards the security aspect to it. You don't have that's like one part of it, and then the other part is that you have security professionals who obviously are much more difficult to get to as a company and to hire. But so it's really about empowering people to know how to get started with cloud-native security and how to choose tools and implement them and use them in the most effective way. And it all boils down to establishing a security-centric mindset in a way. And that's not just saying like everybody should take ownership of security and everybody should work on cloud native security, but there's a lot that everybody within your team can do. Now, the premise is in a lot of my talks that security can be incorporated into all other business functions in one way or the other. Even if you have a security team who's specializing in, or like whose main responsibility is to ensure that your services are secure and have insights into the security of your services, there's something everybody can do on an individual basis as well. So for instance, inside reliability engineering, when we're talking about our different goals as SREs, we can and have to also to a large extent talk about the security state of our application. So for instance, when we're talking about how do we scale our application, how do we meet demands on a fluctuating basis, we also have to talk about how do our services stay secure at the same time doing scaling up and down. And then similarly, when we want to talk, or when we're talking about the visibility, gaining insights into our application, how our application runs, we also should talk about how do we gain insight into the security state of our application. What would that look like? Where would we gather those insights? How do we make the security visible in the first place? And then there are other parts to site reliability engineering that are actually highly applicable to security. For instance, we are talking about reducing noise toil in SRE a lot, and that's similar to with security scanning. A lot of times we are bombarded with security issues and we don't know where to start, and a lot of it can be just noise that's just that we don't really know how to deal with, like anything that we don't really have actionable items to, that nobody really has ownership over, but it's just information that's there, can be noise, right? It can be useful information, but if not dealt with properly, it's just noise. Other things are communication and ownership. So in the case of SRE work, a lot of times you have run books, you have documentation, how to deal with different incidences, and that documentation is there to empower people, right? If somebody is on call, I was on call a lot of times, and I was junior SRE to a large extent, right? I didn't, like, the first time I dealt with incidences was during that first role. And the documentation in those run books, they really help you to work through it, of like when you see service going down, okay, what are the next steps that you do to figure out what went wrong and how do you fix it, or at what point do you ask somebody more senior to come on and help out. And something similar has to be done with security ultimately. If there's a security issue of any sort, people within your organization should be empowered to know what to do, what kind of steps to take. So it all boils down to a large extent to shared ownership and consistent communication. Now I say shared ownership, and I'm going to talk about that a little bit more, because I don't think one person should take all of the ownership, and at the same time, not everybody should take ownership of everything. So once we are there, once we want to get started with cloud native security, how do we actually approach it? How do we go about it? Once we know, okay, we want to get started, how do we actually get there to empowering people to get the right information and so on? Well, first of all, you have to understand your needs based on your team, based on your goals of what are you trying to achieve? What is it, why do you want to implement security tooling? Do you want to make your services more robust? Do you want to gain insights? Do you want to implement compliance frameworks? What is it that you want to gain out of it? Or maybe you just want to implement it into your open source project to make it look better to contributors as well as to users. So this is taken from a blog that Vice Engineering team wrote about how they kind of changed up their entire security scanning stack, like all of the different tools that they were using for their security scanning and to gain insights on the security state of their services. And there are 4 goals that they defined as part of it, of like what they wanted to achieve before they got started changing things around. Let me just give my puppy something to chew on because she's really noisy in the background and I don't know if you can hear that. Sorry for that. I just don't want it to be too distracting, especially for me. So the first thing is that they wanted to assign ownership of vulnerabilities. And that's something that's not done a lot. That's a lot of times missed on. A lot of times we have like a list of vulnerabilities, but if somebody or like if everybody's supposed to look at those vulnerabilities, then 2 things might happen. Somebody in your team might try to fix them all, or people might look at them and not quite know which actions to take and how to take care of those vulnerabilities. So you really want to assign ownership of different vulnerabilities for different parts of your resources, of your services. The next thing is that they wanted to have a global view of the security state of the services. So a lot of times we're looking at the vulnerabilities, for example, for a specific application, for a specific service. And what happens is when we break it down is it's obviously really useful for the person who's working at that particular part of the service, right? But ultimately, when we want to make large-scale changes within our team, when we want to change up our workflows, our processes, it's not too helpful to have all of the different components broken down. It's much more helpful to have a global view of like your total number of vulnerabilities, your total number of critical vulnerabilities. What are the misconfigurations? Where are they in your application stack? And then see how different changes within your processes actually affect those vulnerabilities or like those security issues. For instance, if I have continuous security scanning within my running infrastructure and have a global view of the reports that this provides, then I can see like, okay, if I implement a new security scanner or if I implement a security scanner in my CI/CD pipeline before the infrastructure actually gets deployed, does it change something in the security issues of my infrastructure, right? Things like that. The third thing is what they wanted to achieve was develop dashboards for different users and requirements. Now, this is opposite to the second point of like, you actually want to be able to break down the dashboards, the information that you are provided from your security scanning, from your reports. And the last thing is overcome difficult to use in different UIs. A lot of times, especially also within the cloud native space, when we're getting started with a new tool, we end up having a new dashboard, a new platform, a new UI to get used to. I remember when I got started with Prometheus and Grafana and like their query languages for Prometheus, PromQL, as well as the Loki query language and so on. It's difficult to get started with those monitoring observability tools and to make the best out of them. Like that can be a really steep onboarding curve. Similarly, when like every time you're using a new dashboard, you're using a different process. People will have to get used to it and understand what's going on and how to make the best out of that. So the more you can reduce it, the more you can reuse the same dashboards, the same platform, the better it is for your engineers, for your team. So once you know what you're actually trying to achieve, what are your goals, it's about selecting a tool. Now, this is an overview graphic I made with the help of my Twitter community. These are all open source security scanners focused on cloud native, on the cloud native space. So there are lots of other security scanners that are not necessarily Kubernetes cloud native focused. These tools are really focused on container scanning as well as Kubernetes focused workloads. So I broke it down into different types of scanning. So for example, scanning for vulnerabilities, scanning for misconfiguration issues, scanning for compliance, and similar. And you can see that a lot of these tools are really focused on one of these areas, one of these scanning types. But then there are some tools such as Trivy. Trivy is one of our open source tools at Aqua Security that focuses on all the different aspects in some way or another. Now, choosing one of these scanners will depend on multiple factors, such as the needs, your goals, but also factors such as the size of your team. If you're an individual contributor to an open source project, maybe if you're even the sole maintainer, you will choose likely a different tool to somebody who's working in a large team or across multiple teams. So, for instance, if you're working in a small team and everybody within that team is working with different resources, with different types of resources across your development lifecycle, then you might want to choose the same scanner for all of those different scans. So, for example, from scanning your container images to scanning your infrastructure's code configurations to scanning your running workloads, because that means that you can then transfer the knowledge between the different people within a team, and you don't have to get started individual with different tools. Now, another factor might be the industry you're working in. Some industries are highly regulated, and you can't just go ahead and implement any tool, right? You want to comply with some standards. Now, in other industries, you can just try out what works best for you. And then also the types of technologies you're already working with, and this kind of is highly related to reducing the number of additional processes and platforms that you introduce. So if you can choose a more mature security scanner, a more mature tool that you can already implement and integrate into your existing platforms and other tools that you're using, that will make it much easier to implement the scanning and to actually look at the results and then define action items based on those results. You can see that a lot of the more mature scanners in this space, they will have more integrations available, whether built by the core maintainers, by the core team, or within the community. There are also lots of people who are building integrations, who are expanding the use cases. And similar, I will show later on also a dashboard that was created by somebody within the Trivia community. Now, other factors that play a major role are company goals and leadership and the budget and expertise that are available. Again, it's really difficult in the cloud-native space to find security professionals. So anytime that you can help upskill people towards DevSecOps, towards cloud-native security, it's, I would say, a huge win for any organizations, because it can only benefit further down the line. But yeah, it really depends on, do you have the resources available to implement the tools themselves, whether it's open source tools, you will need to have the time to understand and implement them, or purchasing an enterprise tool obviously requires also the budget for it. Now, additional factors and ways that those tools differ, like once you understand the different types of tools and which tool you kind of want to go with, depending on these factors and depending on your needs, you might also want to look at the different ways that those tools differ. So let's say you have to decide between two different tools. You might want to focus on these 5 different components of, like, the first thing is the installation. That's one way that security scanners differ quite a bit. A lot of scanners are either installed as like a CLI tool, either locally on your terminal in your CI/CD pipeline, and then you can just run ad hoc security scans with the commands. Now, other scanners that are, for example, focused on Kubernetes environments, resources, are installed as like Kubernetes resources within your clusters, within your infrastructure. And in that case, you want to also make sure that you understand what is installed, like what Kubernetes resource type is getting installed. Some scanners, they will run a job inside of your cluster. Like they will basically, once you trigger the scan, they will spin up a job inside of your cluster and then perform the scan, and might push information from inside of the cluster out of the cluster to your external tools. Other scanners, they might install an operator or similar within your cluster and then perform the scans from within. And then you have to connect those reports, connect the security scanner with other tools to get the reports to make them more accessible and similar. So there are some subtle ways that those tools differ. The main difference is really like, is the tool installed within your cluster and then performing all of the scans within, or is the tool actually outside of your cluster and installing something inside of your cluster and needs access and then pushing information out? Because depending on that, the access rates of those resources of those scanners will differ, and it's generally best practice to not pull information out of your cluster like from external tools. Next thing is scan coverage. Most of these scanners take, for example, vulnerabilities from a similar vulnerability databases. Some of them differ. For instance, at Aqua, we have an in-house research team that it deploys honeypots and then sees how attackers are using them and tries to find new vulnerabilities through that and security issues. And that information is then feeding into our security scanners. Now, other security scanners, they will pull at different times and in different ways from different databases. And that's how, when you're comparing security scanners, they will differ in those ways. They will maybe show you slightly different information, depending on which scanners you look at. Then the fourth thing is, and I kind of mentioned that before already, is integrations. Depending on the maturity level of the tool, they will have more integrations with other tools available. And the last thing is that some tools focus more on engineers, and other tools will focus more on cluster admins or security professionals. So depending on which tool you go with, you want to make sure that it's also as useful for ultimately the end user, the person who's using the tool in the end, not just a great tool. So I'm going to focus the next slides on Trivy, just as an example. Now, a lot of the things that I say is applicable across security scanners, but I'm going to focus on Trivy just because that's the tool I'm familiar with. And just mentioning it, it's all open source. To use Trivy, you don't have to sign up. You don't send us any information to Aqua, and Trivy is standalone project. It's not that you automatically, it's not that there's a Trivy and then a Trivy Enterprise for which you, there is a Trivy Enterprise, but it's it's Trivy plus all the enterprise features. It's not Trivy plus additional features that you can't access otherwise. Just mentioning that. So Trivy has lots of different use cases. There's lots of different types of scan that it can do across your development lifecycle. So for instance, when you're choosing a library, when you're choosing packages, you can scan those for vulnerabilities. Then when you package up when you containerize your application, you can scan the containers for vulnerabilities. Then your infrastructure as code, whether that's your Docker file, your Terraform, your CloudFormation. And then we're moving more towards runtime security and implementing continuous scans inside of your Kubernetes cluster. You can also now scan your AWS account for security issues. So we're going to implement also different types of cloud providers, but we started with AWS. And yeah, one of the big things that I'm also going to show you in this presentation is in-cluster scanning through the Trivy operator. Now, once you have chosen a tool, you want to go ahead and set it up and make sure everything is running properly. So here's an example application that I've just that I've built. So in this example application, I'm basically deploying Prometheus with Grafana, and then also Promptail and some other tools inside of my cluster to gain access to basically the telemetry of my different resources. And in addition to that, I want to deploy my security scan, in this case, Trivy. So the first thing is when you get started with a new tool, and this is really applicable across any cloud-native application, not just applicable to security scanners, but you want to identify, first of all, the best installation option that's there. And usually most of these tools, they have a Helm chart available. And that's my preferred installation option because Helm allows me to modify, reconfigure the charts, the Kubernetes manifest, ultimately what is getting installed in the end on an individual basis. And then also through, here you can see in this in these configuration files, that's where I basically configured what I want to change in each of those Helm charts. And this makes it possible if I define it in YAML manifest, the changes that I made, then I can track those changes over time. Now, there are also other different installation options. You can also directly install the Kubernetes resources without Helm. A lot of times I just prefer Helm. Then once you decide upon the configurations that you want to change, you need to test the configurations quite thoroughly. The thing is that a lot of these tools, right, they will have demo examples, tutorials, and so on their documentation sites. But the problem with those demos is that most of the time, they never work for your specific environment in the way that you want to spin up resources or install resources. And also every time I get a question related to Trivy, my answer will vary depending on your environment, depending on your use case. So you really want to test the installations properly and then ensure everything is working together. And those are probably the most difficult steps. I have this demo repository with all of the different installation steps at the end linked, so you can check that out. It's on one of my GitHub organizations. So what does the Trivy operator do? The Trivy operator is basically responsible for in-cluster scanning for Kubernetes manifest scanning, but within your cluster. So you can scan with Trivy just Kubernetes YAML manifest, like just the static YAML before it gets deployed, or you can do continuous in-cluster scanning through the operator, through the Trivy operator. Now, if you're familiar with Kubernetes operators, it's a standard Kubernetes operator. I will go in the next slide in more detail what an operator is. And you just install it along your other resources. So for example, in this case, in this drawing, I have an application namespace with my application, whatever the application is, and then a monitoring namespace with my monitoring tools. And then alongside that, I would just have another namespace with the Trivy operator, and I can specify what the Trivy operator is supposed to scan. Now, an operator is kind of like a controller. They are quite similar in Kubernetes. And controller, basically, they have a control loop, something I have to do on a continuous basis. And basically, the operator does that and then is told to perform specific tasks based on the scans. So for instance, the Trivy operator will scan the resources within your cluster on a continuous basis. And whenever there's, for example, a new container image or the tag of a container image changed or similar in that cluster, it will perform a new vulnerability scan on that container image. And that happens on a regular basis. And in addition to that, every 6 hours, it will pull the information from the vulnerability database to have the most up-to-date scans for your resources. And it does that not just for vulnerability scans, but also for misconfiguration scans and all kinds of other scans. I'm going to show them in a second as well. The beautiful thing is, if everything is a Kubernetes resource, you can use the same processes across your stack. And that's kind of related to what I mentioned earlier. If everything is a Kubernetes resource, everything that's installed within my cluster, then I can use the same tools to manage those Kubernetes resources. So I can use the same pipelines, I can use the same processes, platforms, everything to manage my security tools as well as my observability tools on my application, which makes it a lot easier for DevOps folks, SREs, to, for example, get insights of my application, but also for engineers to integrate their tools and resources within the processes. So this is what you will see as the Trivy operator and the Trivy system namespace. Now, these are not the CRDs, the custom resource definitions that get deployed in Kubernetes, but just the pod that's running, like the container image, the service with which you can access mainly the metrics of the Trivy operator. And then it's just basically, it's a replica set deployment running within a cluster. It's very like when you install for the first time the Trivy operator, there might be a lot of information, a lot of stuff that gets installed in your cluster, but most of it are CRDs, custom resource definitions, and ultimately you will just deal with the pod and with the service itself. Now, once you open the service, you can see at the metrics endpoint the different metrics from your scan reports. Now, this is not a scan report. A scan report would be a YAML manifest that details that it's a scan, that's a vulnerability scan, and then it details, it provides lots of information on that vulnerability scan. These are just the metrics that are taken from these reports. So here we have, for example, the metrics on our vulnerability reports, and it shows me how many, for example, medium vulnerabilities I have within a namespace within that image, Grafana Loki. And it just details like all of the metrics of those vulnerability scans across my cluster. Similarly, it's also checking for exposed secrets within my cluster. So it will scan my entire cluster and see, like, are there any secrets that are not configured properly, that are exposed, that people who have access to your cluster, access to a namespace, could access as well. And then it's detailing them as well as reports, but the reports are, this is not the report. Again, like, don't think this is a report. And these are just the metrics from the reports. And then we also have the RBAC assessment checks. So basically, which application has access to what? Are there any misconfigurations in your RBAC roles? And then we also have config audit reports, which are basically misconfiguration issues within your application stack. So anything that is misconfigured on for example, if you deploy your manifests, your applications with Terraform, is there anything misconfigured within your Terraform deployment? Is there anything misconfigured within your Kubernetes resources? And those will be detailed in the config audit reports. Now, once you have access to the metrics from your scans, from your security reports, you can visualize the state of the services through dashboards. And this is the dashboard that I mentioned earlier. It's from somebody in a trivia community, they built this dashboard, and it just breaks down all of your vulnerability scans in this case into different, into the different severity of those vulnerabilities that have been found. So in total, this cluster has 175 vulnerabilities, and of those 18 critical vulnerabilities. Those are the vulnerabilities I want to take care of probably much earlier, sooner than later. And the chart obviously tells me over time how did the number of vulnerabilities change in my application. Now, once you have access to those vulnerability scans, you want to make sure that you avoid vulnerability hell. Now, what do I mean by vulnerability hell? A lot of times when people first run security scans or, for example, vulnerability scans on their resources, they're bombarded with a high number of vulnerabilities. So for instance, in this case, Alex Jones tweeted, "I just give up and die now then," having over 550 vulnerabilities in their resources. I don't know what kind of resources they scanned, but those are a lot of vulnerabilities to fix, to take care of. Now, in this case, they're already divided by severity. So the 3 critical vulnerabilities should be pretty straightforward to take care of. But ultimately, the problem is with, if you look at the vulnerabilities as like a whole numbers, that a lot of these vulnerabilities are likely not even applicable to their environment, to their specific use case and existing resources. So some strategies on how you can avoid vulnerability hell is, first of all, ignore all but critical vulnerabilities. Okay, just take care of those 3 critical vulnerabilities. That's pretty straightforward, and then address the rest. The next thing is don't scan everything at once. Scan the most critical resources within your application stack first before you scan everything else. There's really no need to scan all of it at once. Then filter by vulnerabilities that have a known fixture available. There's no need, or like little need, to look at vulnerabilities that don't already have a fix available. Now, if you're about to choose a container image with lots and lots of vulnerabilities that don't have a fix available, then you might want to see if, even in that case, if there's an alternative that you could use. The next thing is filter vulnerabilities by team and by application. Really make them applicable to your use case and to the person who's dealing with those resources. So there's, again, it's related to what I mentioned earlier, that not everybody should take care of everything. Really assign ownership. And it's like a lot of times we talk about shifting left, and everybody should be empowered to ensure that your application is secure and similar. But ultimately, that in those cases, a lot of times, if everybody's empowered to do everything, nobody will do anything. And that's kind of a problem, especially in the case of security. And the last thing is make vulnerabilities context specific. So give them additional information. And one way we can do it is to give them more context, is to correlate the metrics from our security scans with other metrics, with other dashboards, other reports of our application. So some other ways that we can make security issues more visible, for example, by setting up alerts. So if everything is already within our Grafana dashboard, within Prometheus and Grafana, we can also set up alerts, like how we set up alerts if a service is down through Prometheus, through, for example, Alert Manager and Prometheus. We can also set up alerts through Alert Manager and Prometheus or through Grafana directly. That's one way to do it. And the goal here is really that it's easy to ignore vulnerabilities. So we want to make them scream at us until they are fixed, right? A lot of times we can integrate security scanning into our workflow, into our pipelines. But it's easy to ignore vulnerabilities or to ignore security scans and don't fix them and just say, okay, we will take care of it next time. The problem here is that good thing is that we can deploy resources without having necessarily paid attention to the security scanning, and customers will still be happy. We have to take care of the deployment to make customers happy. We don't have to take care of the security scanning to make customers happy. That's kind of the main difference, that you can have an application service with lots of critical vulnerabilities. Nobody will care until they have to care, and that's in a position that you don't want to get into. The last thing is correlating metrics. Like mentioned, we can give metrics more, we can give our reports more context by correlating different dashboards. So if it's, for instance, this dashboard again is showing the number of vulnerabilities that we have. We can see it went up. And we can correlate it to our other dashboards and see, okay, did a new service get deployed? Did something change within our application that caused the number of vulnerabilities in this case to go up and other security issues? Now, some additional tips, and also just to kind of repeat what I mentioned earlier, is first of all, assign ownership. Don't introduce too many tools at the same time at once. Really start small, start somewhere. As long as you start anywhere, that's great. And then utilize existing platforms, workflows, and processes. There are lots of tools that are already integrated into, like lots of security scanners that are already integrated into other tools. So make sure that you utilize them as much as possible before introducing completely new workflows and new tools and platforms. Now, here are some of the resources I mentioned. The first one is the Vice engineering blog that really detailed describes their journey. Then the next thing is the Aqua open source YouTube channel, where we have lots of tutorials, also deep dives and presentations if you're curious. And then we have the Trivy and the Trivy operator repositories on GitHub and the demo project that I mentioned. And you can also always chat with us on Slack, on the open source Slack. You can also find a full demo of Trivy here from last KubeCon that I gave with a coworker at the time at SecurityCon. So these slides basically have all the different commands and showcase the different features. And yeah, do we have time? Do we have questions? Do we have time for questions?
Of course we have time for questions.
Awesome.
Thanks for the awesome talk.
Thank you.
So, as you already mentioned, yes, Q&A time. So, without further ado, let's start with the first one. How to detect where Kubernetes is vulnerable?
So a lot of times, well, it depends. First of all, it depends what kind of version or what kind of cloud provider you're using for your Kubernetes stack, for your Kubernetes clusters. But ultimately, there are some, if you look at compliance standards and just best practices, Kubernetes best practices, they will tell you some things to look out for. For example, in terms of RBAC for the different access roles and rights within your cluster. There are things that you can do that you should take care of in any production cluster or any cluster. So you can look at these best practices and start there. And then once you have taken care of them, I would implement a scanner inside of your cluster that performs continuous scans and kind of points you to additional resources that you might want to pay attention to. For example, the Trivy operator does misconfiguration scans in your cluster, so it will tell you if there's, for example, a port exposed that shouldn't be accessible, it shouldn't be exposed, things like that. And then based on those reports, you can then take additional steps depending on your application and depending on where your application might need further attention.
All right, thanks for that. Another question would be, what can we do if someone breaks in, even if we have control in place?
If somebody breaks in, so you want to be able, first of all, to identify that somebody has access to your resources, unauthorized access. That's the first thing. So if you have insights to what's running in your cluster and how it's running, then you can see if things are changing. So I think really the first step is having the right tools in place that give you that information. So for instance, you can see in the cloud native space, a lot of people are talking about GitOps, and GitOps is the practices of defining everything that you possibly can in code, which makes it possible to ensure that everything that's defined in your Git repositories is also deployed in your infrastructure. And if that's the case, then you can really see like if there are any changes within your running infrastructure versus to what you actually set up in the code base, in your Git repositories. So these are ways that you can, first of all, identify if somebody has authorized access. And then from there, you obviously want to make sure that it doesn't happen again, right? That you change the access rights, for example, on like whatever happened. Yeah, it really depends.
So many possibilities. But thanks for clarifying that as well. We got another question. What is the best way to secure cluster and workload traffic?
Cluster and workload traffic. So the first thing is that you set up your ingress endpoints in the right way. That's like the first thing, and then the next thing is that you can also deploy like monitoring tools to monitor the traffic that help you also to secure it. There are lots of tools such as Cilium that will help you do that. Now, I haven't really played around with that a lot, so I can't really give a detailed answer on that. Yeah.
Okay. Don't worry. I think most of the audience, and me included, couldn't either. So, but
Next time.
Yeah. Are the pods most important from configuration and attacks to defense?
Are there? Sorry, can you repeat that?
Are the pods most important from configuration and attacks to defense?
It really depends. So generally, you have when you set up the pod, or like the container basically that's running, when you set up the container, there's a lot of things that you can do in the way you define the Docker file, you define how the container is supposed to run and similar. Which if you can take care of that early on before you actually deploy the container in a pod to your cluster, then that will already give you a lot more, or like make the container a lot more secure, make the pod a lot more secure. Now, once you have done that, you want to take care of your infrastructure configurations. And then the infrastructure configuration is really like the next point that will be important in the security of your running workloads. So it's from the way that you set up your Kubernetes cluster to the way you set up the individual applications and containers to the way you define how in infrastructure, how those containers are supposed to run. Now, there are several different points. Now, I'm saying you want to get started early with the containers because ultimately the containers are going to be like, whenever you set them up, the most critical part. If you're looking at the end and at the entire Kubernetes cluster, then you want to ensure that, first of all, I never know how to pronounce it, EM configurations, basically the access rights of, for example, the cloud provider are set up properly. That will be the first step. The next step will be then to look at the configurations of each Kubernetes manifests and so on. But ultimately, that's like the later stage of when you're dealing with the cluster directly. There's a lot that you can do and should do beforehand. The thing is, within your cloud native stack, within Kubernetes clusters, what happens a lot, or like the thing is there, you will have in your Kubernetes cluster, you will have all the attack vectors that you have in a Linux environment, that you have in a container-based environments. But then in addition to that, you have all of the attacks within your cloud native environment. So the earlier you can get started to kind of address any potential security issues, the better, before it gets to the point where you have the running Kubernetes cluster with all of its workloads. I gave earlier this year at OWASP Virtual EU, I gave a talk of one of my coworkers. So I gave his talk because he wasn't able to give it. And he talked in great detail about exactly that. So do check that out. It's OWASP EU something. You should find it on YouTube.
All right.
Yeah.
All right. Thanks for this as well. Next question.
Oh, there's so many. Wow.
Yeah. Right now there are 3 left.
Okay. I'm not used to that. Usually there's no question. Oh, which is great. Like, it's great to have questions.
So let's move on to the next one, which would be Kubernetes is always in desired state automatically because split brain algorithm ? So is this because of split brain algorithm, I think?
So this is related to, again, GitOps and like depending on how you define your infrastructure. So if you so I can make in my running cluster, I can make any changes to any of the resources if I don't have any controllers running that would fix those changes that I made, right? So ultimately, you never want to have people making ad hoc changes inside of your cluster. Like, you want to prevent that as much as possible. To like, even if they have access to your cluster, like if I'm I don't know, cluster admin, I shouldn't make direct changes ad hoc to any of the running resources because you will not know what changes I made. I might not know the next hour or next day what changes I made to any of the resources. So what you want to do instead is define the resources through your infrastructure manifests, and ideally implement something like GitOps, where everything that's defined within your Git repository is then deployed. And in that case, if I would make changes to my cluster resources, the operator, the control loop that's implemented, will just fix them and revert any changes that I made back to what's defined in Git. And that's where you have kind of the additional mechanism in place where it's like preventing me from to make ad hoc changes. But that's, again, more complex to set up. And but by default, once I deployed a resource, then I can make changes to the resource until I redeploy it, right? Like once I redeploy it, then my changes would be reverted. But until that happens, I can just make any changes, pretty much.
All right. Thanks for clarifying that as well. Is it still good for you?
Yeah.
Okay.
Okay. Yeah.
Then next one. How to bring DevSecOps knowledge to a development team? More of a general question.
I think, that's a great question. Because again, when we're talking about shifting left, it's a lot of times we ask, for example, engineers more and more to define the infrastructure, the deployment of the application, and to like package up the application themselves and things like that. And that's great because that's ultimately part of it's needed for the deployment, and they know the application best. So they're part of the application best. So they will hopefully know best how to set up the deployment to a large extent. But what happens with security is that it's something like if it's not properly scheduled in, it won't happen. So a lot of times people might tell me that they do take care of security scanning, but it's maybe at the end of a sprint, or it's on specific days, or it's when there are specific events, then they take care of the security scanning. It's not like on a continuous basis. So if you have already stressed engineers, stressed developers, and you then ask them to also do the security scanning and fix the issues, it might not happen on a continuous basis. So what you can do first is introduce like local tools into their workflow. And for example, Twivi has a VS Code extension. It also has a Vim integration. So whenever they open any resource up in those editors, they can then also scan those resources for security issues, which makes it obviously easier for them to do it. And once you start there, you start small, you can then kind of expand from there and expand the complexity of the security scanning as well. The thing is, with security scanning, it's pretty much you kind of have to convince people to some extent without making it too much of a chore for them to do it. So it really depends also on your team of how you want to, how you're going to implement it. But you have to, I think in either case, you have to really promote it from the managerial level of like, this is something that needs to be done. Versus if you have it from an individual contributor level, you will have people burning out. Some tips there.
Right. Yes, thanks for these tips. Second to last question.
Second to last. You earlier said 3 questions.
Yeah.
I'll get it. I'm joking.
We got one additional.
Yeah. Okay.
What do you think about DevSecOps role? Will it be more popular in most big companies, like in the future or in the near future, I think?
So to me, DevSecOps is more of a term. I think you can be a DevOps engineer who's focused more on security. You can be a cluster admin who's focused more on security. You can be a site reliability engineer who's focused more on security. But DevSecOps itself, like as a term, it's a huge term right now, but I think eventually it will kind of not disappear, but merge more into our existing processes and functions, because it's just needed. And like DevSecOps is really needed in every part of our development lifecycle. It's not just one part. It's not just one thing. It's not just like just the deployment part. It's really like at all different sections of it. So what we see already is that a lot of tools are actually implementing security scanning, for example, into the workflow. So if you have like if you have like, I'm looking for a good example, like a lot of platforms that give you that allow you to deploy resources, like for example, a lot of those engineering platforms where how do you call them again? Platform engineering. You call them platform engineering, right? So platform engineering is like another big term where you basically provide platforms where engineers can just spin up any resource that they need. And a lot of these platform engineering platforms, like dashboards, they already have security scanning in place. So, which makes it a lot easier to just do it along the deployment. And I think that's what DevSecOps will kind of become or move towards, that you just have security scanning automatically provided by any other tool. So you don't have to think about it necessarily separately unless you need specific, really specific features in your scanning or in your security tooling.
All right. Thank you. And now for the really final question.
Really final question. You can also here's my Twitter handle right here. Okay. Twitter handle. So if you have any questions, you can also tweet at me.
All right, then the last question for this live day is, are the TLS and SSH main security concepts even now?
Are they even now?
Maybe if they're on the same level, I suppose, or something like that.
Can you repeat the question?
Are the TLS and SSH main security concepts even now?
I mean, they're applicable. Everything that anything that you do in network engineering, security-wise, is applicable to the Kubernetes, the cloud-native space. That's just it's really it's straightforward, pretty applicable in what you would do on a, I don't know, in normal, let's say, network engineering, you would do also likely in your cloud-native environments. That's just what I would say to that. So yeah, all of those concepts are applicable, are pretty applicable. Yeah.
All right. Thank you so much. Thank you for the awesome talk and the extensive Q&A. I hope you have a nice rest of the day. And we'll see each other
Thank you for
again
having me. Oh yeah, we will. Yeah, it's more or less a workshop what I'm giving. So if you're curious to learn more about all of this, then join the workshop. And I'm
looking forward to it. All right. Have a nice rest of the day. Bye.
Thank you. Bye. Bye.
So, and now that we have our final talk completed, we start with our Deloitte giveaway. First, we have 10 winners who get this goodie bag, or one of these goodie bags, I might say. And the winners are Robin Müller, Jessica Bode, Ömer Bektürk, Christian Koch, Lisette Salinas, Elhem Nouri, Gabriel Rauter, Alex Hahn, Anna Romanova und Gottfried Karl Becker. So congratulations. You will get an email later this day with further instructions on how to claim your prize. And for the main part, maybe you have already seen it, this beauty here. The MetaQuest 2, given out by us and Deloitte, goes out to Christian Löffler. Congratulations. Now that I'm holding it myself, I'm a little bit jelly, I might say. You will also get a mail later this day. And if you didn't win anything, don't be sad, as we also have a giveaway for one of our rubber ducks signed by Håkon William Lee. If you don't believe us, here's a short video to prove it.
Would need to say makes the web a better place still for at least the next 500 years.
So if you like CSS, it will fit perfectly to your desk setup. To win it, just sign up for Dev Digest newsletter. You find the link in the comments. And if you're, apart from Rubberduck, also looking for a new job, just check out our job platform at WeAreDevelopers.com, as we have lots and lots of jobs listed from all over Europe and most of them even with upfront salary information. And as I hope to see most of you soon again, also check out our live events on wearedevelopers.com/live and register for free for the upcomings. The next one will be on November 2nd in exactly 2 weeks, and where we will deal with React. And apart from that, talking about pre-register, don't forget to go to worldcongress.dev to pre-register for our upcoming WeAreDevelopers World Congress 2023 to claim your discount code. All right, hope to see most of you again in 2 weeks when it's all about React. Until then, stay tuned. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.